Broder. I'm a partner instructor with InterNACHI, and I've been performing residential and commercial inspections for about 17 years. So somewhere north of 10,000 inspections under my belt. And, we'll definitely go through this in detail, and I'll be available for any questions you guys have. This is a pretty critical component, as most components of a home inspection are. I mean, safety is definitely the top concern. So anything that has such a heavy impact on safety, like things to do with carbon monoxide or potential fire, fireplaces, stoves, and chimneys, super critical that we get this right. Everybody's looking for a home inspector to miss something. So you don't want to sound alarms about things that are underimportant, but there's almost nothing underimportant when it comes to these particular items, just because of the potential fallout if something is not right. So the goal of the inspection of a fireplace, stove, or chimney is to provide provide observations that may lead to the decrease of hazardous conditions associated with fireplaces and chimneys. If the inspection reveals that an existing chimney is not safe for the intended application, it must be repaired, rebuilt, lined, relined, or replaced with a vent or chimney to conform to building standards. So this is one of those issues that's like, there's not a whole lot of like, well, maybe just have it checked out. It's like, if there's a problem, definitely put it in the red flag issue in your report. So let's go to the next slide here. So the introduction. The scope of the inspection is limited to readily accessible and visible portions of the fireplace and chimney. And we should know that as home inspectors by now, it is a visual only inspection. The inspection is not all-inclusive or technically exhaustive, as are most of our inspections. The inspection involves a visual-only examination of the readily accessible portions of the chimney exterior, interior, accessible portions of the appliance, and the chimney connection. The inspector should look at the general structure of the chimney and any connections to appliances, stoves, and heating systems. The inspector should also look for improper installation, obstructions, and combustible deposits. The inspector should advise his or her client that all fireplaces, fuel burning stoves, and chimneys should be inspected by a certified chimney sweep prior to their first use, and not less than annually. And we'll probably touch on, maybe at the end if we have time, there are like 3 levels of chimney inspection. And so what we're here to do is probably considered a level 1 or maybe even less than that. But what they're saying is you should definitely not less than annually have a level 1 or level 2 inspection. But we'll talk about that later. So the standards of practice for InterNACHI. The inspector shall inspect readily accessible and visible portions of the fireplaces and chimneys, lintels above fireplace openings, damper doors by opening and closing them if readily accessible and manually operable, and clean out doors and frames. The inspector shall describe the type of fireplace. The inspector shall report as in need of correction evidence of joint separation, damage or deterioration of the hearth extension or chambers, manually operated dampers that did not open and close, the lack of a smoke detector in the same room as the fireplace, the lack of a carbon monoxide detector in the same room as the fireplace, and cleanouts not made of metal, precast cement, or on other non-combustible material. The inspector is not required to, doesn't mean you can't in every category, but you're not required by the standards of practice to inspect the flue or vent system, the interior of chimneys or flues, fire doors or screens, seals or gaskets or mantles. Determine the need for a chimney sweep, operate gas fireplace inserts, light pilot flames. I'll say that again, you're not required to light pilot flames. Determine the appropriateness of any installation, inspect automatic fuel-fed devices, inspect combustion and or makeup air devices, inspect heat distribution assists, whether gravity controlled or fan assisted. You're not required to ignite or extinguish fires. Determine the adequacy of drafts or draft characteristics. Move fireplace inserts, stoves, or firebox contents. Perform a smoke test. Dismantle or remove any component. Perform an NFPA style inspection. Perform a phase 1 fireplace and chimney inspection. So even though I mentioned the phase 1 or type 1, definitely don't put that in your paperwork or in your report. Just do it according to the standards of practice and go from there. So a chimney by definition is a vertical shaft through which smoke and gases from fuel burning heating systems, stoves, appliances, and fireplaces exhaust. The chimney may be built of masonry or metal pipe materials. The flue liner, chimney inner wall, or vent inner wall must be continuous and free of cracks, gaps, and perforations, and other damage and deterioration that could allow the escape of combustion products, including gases, moisture, and creosote. Multiple solid fuel venting is prohibited. A solid fuel burning fireplace, stove, or heating system must not connect to a chimney venting another fireplace, stove, or heating system. It's completely prohibited. I haven't looked at it in the 2024 IRC, but if you look at the 2021 IRC, M1801.12, that deals with that, and it's prohibited to have multiple solid fuel venting. Okay, they're not allowed to attach. So a solid fuel burning appliance or fireplace must not connect to a chimney that serves to vent another appliance. Each solid fuel burning appliance or fireplace must have its own dedicated independent chimney or vent. Solid fuel burning appliances must not share a chimney with any other appliance or fireplace. And if you can't tell, I've repeated it a couple times, can't be done. And so here's why. Solid fuel burning appliances produce creosote in the interior flue liners of chimney stacks, and creosote is highly combustible. If you have a chimney fire, it's usually because of creosote buildup. So like I said, anybody who knows somebody who's had a fire, my parents moved into a house. There was a nice shed out back that was kind of served as a man cave for my dad. There was a chimney already there, but without a fuel burning appliance. And so he installed a wood stove, or had somebody install a wood stove without ever having the chimney cleaned. My brother, who's a firefighter, was thrilled. And that's what happened, is he lost the whole shed because the creosote inside that flue pipe had built up, and it's highly combustible. So if there's a chimney fire, other connections to the chimney could allow the fire to travel out of the chimney and into the home, or in the case of my dad, into his wonderful man cave that I did have some belongings in, but no big deal. Chimney passageways can become partially blocked by creosote formation, which can force vent gases from another appliance to exhaust back into the home. So anytime you obstruct that flow, it doesn't have good results. You'll have heat buildup, you'll have pressure that forces those gases back into the home or out of any loose connections and things like that. An appliance must not be connected to a chimney flue serving a separate appliance designed to burn solid fuel. So it's not just two solid fuel burning appliances, but anything that has a solid fuel burning can't have, it has to have a dedicated chimney flue. A solid fuel burning appliance or fireplace must be connected to a dedicated independent chimney or a dedicated independent flue inside a multiple flue chimney construction. Solid fuel burning appliances and fireplaces cannot share a common chimney or flueway with any other appliance or fireplace. So in case you haven't noticed, there's a recurring theme here. We're emphasizing it for a reason. It's not up to code. It's not good. Obviously, we don't say code in our reports, but code is a safety guideline in a lot of instances. Okay, it's best practices and it's safety. So it's a huge safety concern. And so it's something that if you recognize that a solid fuel burning appliance is sharing a flue with another appliance, any other appliance, call it out immediately in the report and say, this is like immediately in need of correction. This needs to get fixed before this house gets sold. Combination dual fuel, gas or oil, and solid fuel burning appliances are designed to be connected to a single chimney passageway. Such dual fuel appliances must be listed, labeled, and installed in accordance with the manufacturer's instructions. Again, you can refer to the 2021 IRC. That's in G2427.5.6.3. And if you guys have, I assume that you guys have all taken this course on InterNACHI. And if not, just shoot me an email, shoot AJ an email. We can get you the PDF of this exact training just to kind of catch some of those code references and things like that. So gas and solid combo appliances. A combination gas and solid fuel burning appliance may be permitted to be connected to the same single chimney flue, but there has to be a manual reset device to shut off the gas to the main burner in the event of sustained backdraft or flue gas spillage. Further, the chimney flue must be sized to properly vent the appliance. The dual fuel appliance is not very common. So it's probably not something you're going to see. Maybe some of you guys have, but not super common, just important to know. So chimney and vent connections. As you can see in the picture here, connectors are used to connect fireplaces, stoves, and heating systems to a vertical chimney or vent, except where the chimney or vent is directly attached. So obviously, if there's a chimney going off of something directly out of the roof, these connectors aren't needed. But when there's an existing chimney and somebody's tapping into it, this is how they do it, these connectors. Connectors for oil and solid fuel burning appliances must be made of factory built chimney material, type L vent material, or single wall metal pipe that is resistant to corrosion and heat. Obviously, for obvious reasons, you'd want something that has a high limit on heat. The pipe thickness should be a certain minimum of galvanized steel. For pipes 6 inches or smaller, the minimum is 26 gauge galvanized sheet metal, which is already pretty thin. Connectors must be accessible or removable for inspection and cleaning. Unused openings in chimneys and vents should be closed. At the masonry chimney flue, the connector vent pipe must connect at a point at least 12 inches above the lowest portion of the interior of the chimney flue. Some building codes provide only for 8 inches. Connector vent pipes should be installed in accordance with the manufacturer's installation instructions. That's always true. If you have access to manufacturer's installation instructions for anything that you're looking at, always good to reference those if you're going to call something out, because maybe something is a little bit different than you're used to seeing, but it would be good to know if that particular manufacturer has some variance built into their manufacturer's installation instructions. And if any code buffs know, a lot of times building code will have a guideline, but if you get in contact with a building code professional and ask them about some kind of a variance, usually they're going to say, what does the manufacturer's installation instruction say? And they're going to default to that. So length and slope is another good thing for us to look at as home inspectors. Stoves and heating systems shall be located as close as is practical to the chimney. Connectors must be as short and as straight as possible. An old general rule of thumb for the maximum length of an uninsulated connector pipe to a natural draft chimney is 10 feet. In the 2018 International Residential Code, section M1803, that states that the horizontal run of an uninsulated connector pipe to a natural draft chimney should not exceed 75% of the height of the chimney above the connector, if that's easy enough to follow. The horizontal run of a listed and labeled connector pipe to a natural draft chimney should not exceed 100% of the chimney height above the connector. Connectors should be sloped at least 1/4 inch of rise per foot of run. And fastening, all the joints should be fastened with sheet metal screws, self-tapping screws, or rivets are even better. Passing through, a chimney connector pipe or vent connector pipe should not pass through any floor or ceiling. It should not pass through a wall either, unless it's listed and labeled for a wall pass through. A single wall metal pipe used as a vent connector passing through a wall, ceiling, or floor must be guarded by a ventilated, non-combustible metal thimble and must maintain a minimum clearance of 6 inches between the thimble and any combustibles. A non-combustible thimble must be used where a single wall metal pipe passes through a roof constructed of combustible material. Most roofs are, again, not all roofs are, there are metal roofs and things like that, but 80% of residential roofs are made of combustible material. It would be uncommon to find a single wall metal pipe passing through a ceiling, wall, floor, or roof. For unlisted single wall chimneys and vent connectors, a single wall metal pipe used as a vent connector must maintain a minimum clearance of 18 inches between the metal pipe and any combustibles. Because again, if it's single wall, you got to be thinking single wall, it's going to be building up some serious heat with the exhaust gases inside that pipe. And so that conduction is not much through a thin wall of metal. 26 gauge is the minimum. Thick or thin, it's going to be a lot, very hot to touch. So you're going to need to maintain good clearance through a single wall pipe passing through anything. No reduction. Hopefully this is obvious to you guys, but the size of a connector pipe should not be smaller than the flue collar of the appliance, right? The pipe should not reduce or restrict itself. It's called bottlenecking, and you really don't want to see that. Inlet. The vent connector is causing improper venting here. So inlets to masonry chimneys must enter from the side. Inlets have a thimble made of fire clay, rigid refractory metal, or metal that will prevent the connector from pulling out of the inlet or from extending beyond the wall of the liner. As you can see in the diagram there, if the vent connector extends too far into the chimney, it may prevent proper venting. Now on the outside, the 3-2-10 rule for masonry chimneys, right? The chimney should be high enough to prevent downdrafts caused by wind. So the 3-2-10 rule for masonry chimneys is that masonry chimney should extend at least 3 feet above the highest point where the chimney passes through the roof 2 feet above any portion of a building that is within 10 feet distance horizontally. Okay. So 3 feet above the highest point where the chimney passes through, 2 feet above any portion of the building that's within a 10-foot distance horizontally. Chimney should be high enough to prevent downdrafts. Remember that. All right. Now we'll talk about clearance. There's a nice, if you guys don't use these glossary images, I use them kind of incessantly because they're really, really good. And frankly, AI is not quite there yet as far as art goes. So the InterNACHI gallery is really, really good. So fire blocking or clearance rather. House framing components should be at least 2 inches away from the chimney wall. Open spaces between the chimney wall and the combustible building materials should be sealed and insulated with non-combustible material. Fire block. Oops, sorry about that. Scrolling on the wrong page. Now, masonry chimney footing. So now we're going to the bottom of the chimney. A masonry chimney has its own footing and is built in such a way that the chimney provides no support to nor receives support from the house structure. The chimney footer may be connected with the house foundation and footing. So that's an important thing to remember, is that the chimney, in some sense, obviously it's connected to the house, but it doesn't need to be pulling on the house, and the house doesn't need to be pulling on it. It's got its own footer. So footings for masonry chimneys must be made of concrete or solid masonry, at least 1 foot thick. They should extend at least 6 inches beyond the face of the fireplace or foundation wall on all sides. Footings for masonry fireplaces must extend below the frost line. They must be installed on natural, undisturbed earth or engineered fill below frost depth. In climate areas not subject to freezing, the footings should be installed at least 1 foot below the finished grade. Chimney lining. All masonry chimneys must be lined. The chimney lining must be appropriate for the type of fireplace, stove, appliance, or heating system connected to it. The walls of the masonry chimney having a clay interior flue should be at least 4 inches thick, considering a standard brick is 3 5/8 inches wide. The minimum standard thickness for a clay flue liner is 5/8 of an inch thick. The 2018 IRC states that the bed and head mortar joints should be 3/8 of an inch thick. In the United States, common dimensions of a masonry brick are 3 5/8 inches wide, 2 1/4 inches high, and 7 5/8 inches long. The actual dimension is the measurement of the brick. The nominal dimension is the measurement of the brick in 1 mortar joint thickness. So the nominal thickness of the brick wall at the masonry chimney must be at least 4 inches, right? So 3 5/8 inches plus mortar joints. The 3 5/8 inches wide for the brick, 3/8 of an inch for the mortar joint. In the inspection image above, taken of a brick chimney stack for fuel-fired heating systems, the blue arrows indicate the nominal thickness of the chimney wall. The size of the chimney depends on the number and size of flues. The flue for a heating system or fireplace should have enough cross-sectional area and height to create an adequate draft. Now we'll talk about clay lining. So masonry chimneys have a clay, ceramic, cast in place, or metal conduit flue lining. Pay no attention to the crazy tarred up flashing. A chimney without a flue lining is considered a material defect and should be reported. Again, these are not things that are like, well, it's grandfathered in and who cares. There are some items like that. And I know that whenever you say code, it's really, sorry, Gilbert. Yes, you guys are good. We can't hear anything from you guys. So if you got a kid or a dog in the background, don't sweat it. We can't hear anything. So again, material defect, if a chimney does not have a flue lining, okay, that's a huge problem. It's a huge concern for gases. It's a huge concern for heat. And so, you don't want to have inspected something and made a bad assumption that something might be grandfathered in, or I don't want to blow up the deal or whatever it is that the line of thinking is. And then next thing you know, you're reading about that in the newspaper or I hesitated to say newspaper because I know there is no such thing anymore pretty much, but you don't want to be on the news having missed a big issue like a missing flue liner and have the whole house burned down, right? So that's absolutely not something we want, and not just from a liability perspective, but for the safety of the people that we're dealing with, right? We care about our clients. We want them to be safe. So the purpose of the flue is to contain the combustion products, direct them to the exterior, and protect the masonry chimney walls from heat and corrosion. Because even though we use fire brick, Like bricks are obviously very resistant to heat and very resistant to corrosion, but that's not necessarily true of the mortar joints, right? So that's going to be the thing that breaks down fastest. And if it's not protected, those mortar joints are really going to start to break down. So a masonry chimney without a flue liner must be professionally inspected and corrected by a certified chimney contractor who will make repairs or replacements so that it meets modern safety standards. Clay tiles are the most common type of masonry chimney liners. Clay tile flue linings can be square, rectangular, or circle. The clay lining in the inspection image above is square and serving an oil-fired forced air furnace in the basement. So there's two different ones. Obviously, there's the one on the left that appears to be more rounded, and then there's the one with that kind of old chimney is a bit more squared off. They come in different sizes, diameters, cross-sectional pieces. The general rule is that a single flue should be used for only one heating system. You may find the vent from a gas-fired furnace and a gas-fired water tank connected to one flue. The clay flue lining should extend above the top brick course or masonry cap a minimum of 4 inches, and you can see that in that picture above. The masonry cap must be sloped in order to direct water away from the flue and off the chimney top. So again, by and large, that is done correctly. It's starting to break down a little bit. You can see some cracks in the crown there, but it's doing okay. Metal flue lining and cast in place lining. So metal chimney flue liners are usually made of stainless steel or aluminum. They are used to upgrade and repair existing masonry chimneys. Stainless steel is suitable for wood burning, gas, or oil applications. So a lot of retrofits will use this. Aluminum is an inexpensive alternative only for certain medium efficiency gas heating systems. Cast in place linings. A cast in place chimney flue liner is made of a lightweight cement-like product installed inside the chimney. The cast in place lining is a smooth, seamless stack, and that's kind of one of the biggest benefits of that cast in place system is that there's no seams in it. It can help correct the structural integrity of an old chimney. Cast in place liners are suitable for all fuels. So cast in place is really your gold standard there. Now, fuel gas termination. It's a common mistake to apply the height requirements for chimney terminations, right? The 3-2-10 rule we just talked about, to fuel vents, which can cause vents to extend above roofs much higher than needed in most cases. For example, vent pipes terminating above roofs having a slope 612 need only to be 1 foot high. Okay, this is very different. So don't apply that same rule we talked about, the 3-2-10 rule with a masonry chimney. Don't apply that to fuel vents. The type of venting material is dependent upon operating characteristics of the appliance being vented. If you're inspecting a roof, don't touch these because they are very hot usually, just so you know. Positive or negative pressure within the venting system. And sorry, the type of venting material is dependent upon the operating characteristics of the appliance being vented. Appliances can be characterized with respect to positive or negative pressure within the venting system and whether or not the appliance generates gases that condense in the system. Regardless, all appliances must be connected to venting systems. The venting system must never extend into or pass through any fabricated air duct or furnace plenum. It must convey an adequate positive flow of flue or vent gases directly to the outdoors. There's several types of venting systems that can be used, including plastic piping, special gas vents designed by the manufacturer, and masonry, metal, and factory-built chimneys. Gas vents that are 12 inches or less in size and located at least 8 feet from a vertical wall or similar structure should terminate above the roof in accordance with the gas vent terminations table. Feel free to take a screenshot of that. These requirements indicate that a greater vent height above the roof is needed as the roof pitch approaches being a vertical surface. The greater the roof slope, the greater the effect of the wind hitting the roof surface. Gas vents that are greater than 12 inches in size or that are located less than 8 feet from a vertical wall or similar structure should terminate at least 2 feet above the highest point where they pass through the roof, and not less than 2 feet above any portion of a dwelling within 10 feet horizontally. There are other requirements for direct vent fireplaces, appliances with integral vents, and appliances using mechanical draft fans. So let's talk about some of those vents, type B and type L vents. A type B or type L gas vent must terminate at least 5 feet in vertical height above the highest connected appliance's draft hood or flue collar. A type BW gas vent must terminate at least 12 feet in vertical height above the bottom of the wall furnace. Gas vents shall extend through the roof flashing, roof jack, or thimble and terminate with a listed cap or assembly. Type B vents are vents suitable only for listed draft hood equipped gas-fired appliances, including most domestic heating and hot water systems. They may not be used with any of the following appliances: wood-burning appliances like fireplaces and wood-burning stoves, incinerators, oil-fired equipment, coal-fired equipment, any appliance that burns anything other than liquid petroleum or natural gas, or any appliance that produces flue gases that exceed 480 degrees Fahrenheit or 249 degrees Celsius. Type B vents must be equipped with their own special chimney caps. If the chimney cap is damaged or lost, it must not be substituted with something not recommended by the manufacturer. The clearance required from combustible materials is printed on the flue's exterior metal surface, and it's generally 1 or 2 inches. Type L vents are designed for venting approved oil-fired and natural gas appliances that produce draft hood flue gases that do not exceed a temperature of 550 degrees Fahrenheit or 926 degrees Fahrenheit for 10 minutes in an overfire situation. The minimum clearance from combustible materials is generally 3 inches for type L vents, and they should not be used to vent coal or wood-fired appliances. It can definitely be difficult to tell the difference between type L and type B vents because they're made from similar components, but the vent type should be clearly printed on the vent itself. And again, if that's not, and it's not easily distinguishable for you, you can disclaim that in the report and recommend that somebody else check who's qualified to do that. Both are double walled, although type L vents generally have a stainless steel inner wall and type B vents do not. Regardless of the vent type, InterNACHI inspectors may check for the following defects: deterioration of the outer wall, which is likely caused by failure of the inner metal lining, right? So the inner lining is going to handle most of that heat because it's double walled. If that's failing, it could be exposed to excess heat, like on the type L vents. You'll have that stainless steel inner wall. That stainless steel can handle some pretty good heat. And then if it's failing for any reason, it's going to be letting some of that heat out to that galvanized outer wall. Violation of roof clearance requirements, right? These are things you guys can look for on site regardless of the vent type. All metal vents must terminate 2 feet above the roof surface and at least 2 feet above any portion of the building within 10 feet horizontally. You can check for missing components, like a missing chimney cap is a big one for a couple reasons. Fire stops not installed at either the top or bottom side of the joist where the vent passes through the floors of the roof. The fire stop should allow a fire resistance rating equal to or greater than the floor or roof assemblies through which the vent passes. Blocked bird screens, often caused by freezing moisture in cooler climates. Crucial joists, rafters, or other load-bearing structural members that have been cut to allow for the vent to pass. As you guys know, this is pretty common with plumbers and electrical guys, and it can definitely happen with these chimney professionals as well. They're trying to get a vent to pass through and they make a cut that really doesn't belong in a structural member, especially the easy to notice ones or any structural members that have a cut in that bottom part of it. Plumbing and electrical lines should not be disturbed by the vent, and whether the vent is too high or too low. Manufacturers may set minimum and maximum height requirements for the whole vent assembly, such as air jet type L vents whose minimum height is 6 feet and the maximum is 30 feet. Which, like I said before, if it doesn't look right to you, make sure you know what material you're looking at before you start calling things out as some serious defect or some major problem because you're not used to seeing it. Just educate yourself on what you're looking at. Try to find labels, try to find things that are going to teach you about those items, and then you can do your own research to make sure you're not calling out something that, you know, its max height is 30 feet. It might look ridiculous, but it's in the manufacturer's specs. Inspectors may recommend that extra corrosion resistance for pipes be provided by a stainless steel cap, stainless steel jacketed pipe sections, or stainless steel or aluminum flashings and storm collars. You may also recommend that clients use commercially available combustion enhancing acid neutralizing fuel additives to prevent damage caused to vents by sulfuric acid. In summary, type B and type L vents are designed to vent gases from specific types of appliances and under certain conditions, very generally speaking, right? So 2210 versus 3210, right? We mentioned both of these, and you've got your masonry that's really functioning off of that 3210, and then these type B and type L vents that are functioning off of that 2210 rule. So you can kind of get a visual for that. that 10-foot radius that's coming from that bottom roof with a, sorry, the vent all the way to the right is extending all the way from that bottom roof up above the top roof. So 10 feet, it's got to terminate 2 feet above that upper roof. But if it's further than 10 feet away from that vertical surface, it's just got to be 2 feet away from whatever the nearest thing is, which in the case of the vent on the left, both vents on the left, it's that parapet wall. And again, the diagram is just showing kind of how wind interacts with that and affects the reason why those rules exist. Corbelling and offsets. Masonry chimneys are sometimes corbelled, meaning that successive courses are extended outward. Sometimes corbelling is observed from the unfinished attic space, above the roof surface, or on the side of the house. Corbelling is usually observed in a location of the chimney just before the chimney stack rises above the roof. It could also be at the top of the stack, as in the inspection photo above. So you can kind of see the corbelling on that far left one. It's just a design feature. It also can help kind of move the flue in a direction you want to go without having to take a hard 90-degree turn, right? So corbelling is the projection of masonry in small increments for each course of the chimney. So the chimney should not be corbelled more than 1/2 of its wall thickness from the wall or foundation. A single course is not permitted to project more than 1/2 of the individual unit's height or more than 1/3 of the individual unit's depth. Corbelling can be used to change the direction of masonry chimneys, as shown in the inspection image above. In this unfinished attic, the corbelling creates an offset of the brick chimney stack. The brickwork transitions as it extends through the attic space, and the corbelling should have a maximum offset so that the center line of the upper flue does not fall beyond the center of the lower flue. The cross-sectional area of the flue should not be reduced throughout the offset. These factors are not readily visible or discernible during a visual-only home inspection, but as the case with a lot of InterNACHI courses and a lot of the stuff that we go over, we're going to try to get you guys in the knowledge base similar to a contractor who does these type of things. That way, you're not speaking out of turn. And if you know that something people should be aware of something, but you can't readily see it, it's always good to add the educational information in your reports. My reports usually read like an educational document, so that might be something that you want to put in there. Any one of these sort of rules of thumb, when you recognize that there's corbelling, these are good items to put in your report and just say, hey, here's some things to look for, Mr. Homeowner, because the house that you're inspecting may not be the house that they purchased, right? And so it's good for you to write an inspection report, not only for the home that you're inspecting, but to educate the reader for other homes that they're going to be looking at. It has been my finding that anytime somebody walks away from a conversation with you or a report that you're writing and they've learned a little bit of something, they'll definitely come back to you in the future to get more information, and they view you as an expert. So you guys want to see yourself as an expert, don't be afraid to share free information with other people and educate them. So if the masonry chimney is built with a clay flue liner surrounded by one width of masonry, the maximum offset should be such that the center line of the flue above the offset does not extend beyond the center of the chimney wall below the offset. There are limitations on chimney offsets that provide a gradual transition so that critical stress concentrations at the bottom of the offset are prevented. The maximum offset of the center line of the flue to the center line of the wall of the chimney below maintains structural stability for vertical loads. Corbelling from a wall or foundation. Masonry chimneys shall not be corbelled outward more than 1/2 of the chimney's wall thickness from a wall or foundation. The outward projection of a single course shall not exceed 1/2 the unit's height or 1/3 of the unit's bed depth, whichever is less. What is chimney stack corbelling? Which, I mean, obviously we're talking about it, we're looking at it. Corbelling on a chimney stack occurs when each successive course of the bricks in the chimney is stepped either inward or outward, right? It's commonly used to create a wider lower base that distributes weight and transitions from the narrower section of the chimney near the roof line to the wider base in the areas below. And you see that a lot. You can kind of see it in that middle picture. That's one of the places I've seen it most, is on the exterior of the house, looking at this wide base of a chimney with a big fireplace inside coming down. Again, you're not throttling the flue of the chimney. You're just using the structural advantage of a wider base. So the key inspection points for you guys, The corbelled section is typically where the chimney stack transitions to a different size as it passes from the living space through the attic. So look for any irregularities in the brick stepping pattern, right? And we said not more than 1/2 of the height and 1/3 of the width, the depth. Inspect the mortar condition. Anytime you see any masonry of any kind, definitely inspect the mortar joints between, and in this case, inspect the mortar joints between the corbelled bricks. Mortar should be intact and not crumbling, as weakened mortar can lead to shifting bricks and instability in the chimney. And this is just yet another place where in this course, you're like, I'm worried about fires. I'm concerned with gases, not leaking into the house, and not the least of which, masonry chimneys are very, very heavy. I've seen a lot of chimney collapses. I've inspected a lot of chimney collapses. It's dangerous, dangerous stuff. This stuff's super heavy. So if you start to see spalling on the bricks or cracks in the mortar, disintegration of those mortar joints, definitely call that out in your report and call it out as something that needs immediate attention. Each brick in the corbelling should be correctly aligned with the one below it. So we want to look for that brick alignment. It should only extend slightly outward. Excessive extension or misalignment may suggest poor construction or past repairs. And I'm sure I'm talking to a few experienced guys, maybe a few newer guys. One of the main things that you want to do is look for things that have been so not just signs that something's currently bad, but even signs if something's been recently fixed, right? That's a huge thing with our business because, a lot of times we're dealing in real estate transactions and people want to pretty something up before it gets sold. And so they'll have this repointed very quickly, maybe just by a handyman and not even by a qualified chimney person. So look for these things. Look for the offsets that are not quite right. Look for those mortar joints breaking down. Look for clearance issues, right? Ensure that there's adequate clearance between the corbelled chimney and any combustible materials in the attic, because as they offset those things, maybe they're not paying quite attention to the fact that they're getting closer and closer to a combustible material. And those building codes are usually going to require a 2-inch clearance from any wood framing or any insulation or things like that. So why is this important? Corbelling and offsets can affect the structural integrity of the masonry chimney as it passes through different parts of the home. If there's any failure in the corbelled brickwork or mortar, it can lead to chimney collapse or fire hazards if cracks allow gases or embers to escape into the attic space. By inspecting the corbelling and offsets from the unfinished attic, you can assess the long-term durability and safety of the chimney, which is crucial for preventing damage and fire risks. And again, damage is a huge one. If something like this falls over or collapses, again, I've seen it. I've seen parts of a masonry chimney end up in someone's foyer. It's no bueno. So let's talk about part of the roof inspection is chimney flashing and crickets, okay? If you don't know what a cricket is, some people call it a saddle. It's really just an additional gable roof structure behind a chimney that's 30 inches or more that diverts water to either side of that chimney. So chimney flashing should be installed where the chimney stack meets the roof covering to prevent water penetration. Flashing is typically made from corrosion-resistant metal, such as copper. A lot of times it's aluminum. Most of the time I'd say it's aluminum, more often than copper. Counter flashing is installed in the mortar joints and then folded downward to cover the step or base flashing. And we'll show a diagram of this, but if you guys know how that works, again, you just think about something protruding through a roof. Obviously, that's a fancy hole in the roof, right? So now you've got to allow for that chimney to pass through that roofing structure. You're cutting a hole in the decking. So that decking needs to be protected using flashing. Step flashing is going to run up the sides. Counter flashing is going to be embedded into the mortar joints on the side of the chimney, a masonry chimney, as it were. If the chimney has a dimension parallel to the ridge line, as you can see where he's pointing right there, that backside of the chimney is parallel to the ridge line of the roof. If that's greater than 30 inches and doesn't intersect the ridge line, because sometimes you'll have a chimney that is 30 inches and passes through the roof, but the ridge line runs right along the back of the chimney, that isn't needed for a cricket or a saddle or whatever you want to call it. But if it's 30 inches and it doesn't intersect the ridge line, it's running parallel to the ridge line, a chimney cricket must be provided. Flashing and counter flashing must be installed at the intersection of the cricket and the chimney, and the height of the cricket really depends on the slope of the roof. The lower the roof slope, the shorter the cricket height. And that's really just because that water runoff is going to pick up a lot more speed and a lot more volume of water on a steeper roof. So you're going to need a taller cricket to divert water more quickly to the edges of the chimneys. And it doesn't say this here, but typically the crickets, you're going to want them to extend all the way out to the outer edge of the chimney. It's not necessarily code, but it is a best practice. It's not something I necessarily call out in the report unless I see some existing damage, but you really want to see that saddle or that cricket. The ridge is right in the center of the back of that chimney, and then the slopes kind of go all the way out to the ends, and then there's usually a little, it's not a kick out, but it's part of the step flashing that kind of kicks that water away from running right down there on the side. So let's talk about chimney cap or crown or wash. This is a lot of times a term that gets interchanged with other terms. So we're going to cover it now, and that way you guys will get your terminology straight. How are we doing on time, AJ? Do we need a break soon or are we good?
We got about 5 minutes.
Cool. All right. So all masonry chimneys should have a concrete, metal, or stone cap. So look at the illustrations below or above, as it were, to see the chimney cap identified, right? So it's not necessarily right where you would think it is. A lot of people look at as high as they can go to find the cap. That wash is the chimney cap. So in the illustration, the chimney cap is made of concrete and it covers the top of the chimney wall and covers the space between the chimney wall and the clay tile flue liner. The illustration shows a chimney cap covering the top opening between the chimney walls and the flue liner. The masonry chimney cap, also referred to as the crown, the wash, or the splay, you'll hear a bunch of different terms for it. It's the top element of a masonry chimney. It covers and seals the top of the chimney from the flue liner to the chimney edge, the exterior walls of the chimney. So it's often referred to as a crown because of its form and its function, right? It's kind of higher in the center and washes out towards the edges. Masonry chimney cap should provide a downward slope that will direct water from the flue to the edge of the cap. The crown cap should be formed so as to shed water. So it's kind of like almost like a little masonry mini roof structure to get water off the top of that chimney. The illustration above, it shows a drip edge, and there should be a drip edge installed at the cap, as well as a caulked bond break around the flue liner. And that's something I see a lot. You can see in that lower left picture, the inspector's hand is really close to that caulked bond. Excuse me, I'm just going to sip this water real quick. By directing the runoff from the cap away from the chimney, the overhanging drip edge helps prevent erosion of the brick and mortar in the chimney's vertical surfaces. So when it says drip edge, it's talking about the outer edge, allowing that there's some overhang, allowing the drips to not be washing down the chimney wall, the outside wall of the chimney directly. The crown must be designed for years of weather abuse without cracking, chipping, or deteriorating. A proper chimney crown should be constructed of a Portland cement-based mixture and cast or formed so that it provides an overhang projecting beyond all sides of the chimney by a minimum of 2 inches. The flue liner tile of a masonry chimney should also project above the crown a minimum of 4 inches, and we mentioned that earlier. Now, a metal ring cap and spark arrestor may be installed on a masonry chimney. So remember that term, rain cap, right? Spark arrestor and a rain cap. A rain cap is different than a chimney cap. A chimney cap could also be called a chimney crown. So you could just avoid the word cap when it comes to that Portland cement mixture, allowing the water to wash away. So you've got a rain cap, a chimney crown or a chimney cap, and then the spark arrestor. You gonna jump on and let him go, AJ? Sorry, I saw your face pop up. I thought you were getting well.
Oh no, you still got a couple minutes.
So metal rain cap and spark arrestor, that's that middle picture on the bottom. The inspection image does not have either installed in that lower left, and then the middle one has it installed. The arrestor screen should be made of heat and corrosion resistant materials such as galvanized steel, 19 gauge at a minimum, or stainless steel, 24 gauge at a minimum. The screen opening should be sized to allow the passage of a sphere with a diameter between 3/8 of an inch and 1/2 of an inch. So these are pretty small things. But again, the spark arrestor, as you might imagine, is designed with holes to not throttle down any of the flow of air or gases coming out of there, but you also want any embers and things like that to not be able to be just kicking up out of, especially like a wood burning fireplace, right? So there is a video. It doesn't seem to be in my presentation.
We can skip videos, Matt.
I kind of assumed that we would because we did last time, but
Yeah.
but pretty much everything I just said, it's really just the big thing about not calling a lot of people will see a rain cap. And again, what the inspector's got his hand on right there is a chimney cap. Now, when you see something capping the chimney, that's a chimney cap. When you see it capping the flue, that's a rain cap. They're two very different things. The chimney cap is to not allow any water in between the flue and the chimney wall. The rain cap is to not allow any water into the chimney flue itself. And the spark arrestor kind of helps for animal protection as well, but primarily it's a safety thing, not allowing sparks or really embers or anything that's hot and airborne to get out of that chimney and go cause a fire somewhere. So let's talk about the hearth and the lintel. So the hearth is made up of two parts, the front and the back. The front hearth is located in the front of the fireplace combustion chamber, and the back hearth is located within the fireplace combustion chamber. The back hearth is made up of fire brick that can withstand heat from the fire. The hearth is completely supported by the fireplace structure. The hearth is built initially with framing components that make up the temporary support structure. Concrete is poured and reinforcement is installed in the pour. The temporary support is removed after the concrete is completely cured, so no combustible materials should remain in place under the hearth or hearth extension after construction. You guys, the inspectors, should inspect for hearths that are made of concrete or masonry, and you should inspect for hearths that have a thickness of less than 4 inches. Fireplace lintel. The lintel is located over the fireplace opening and supports the masonry above. It's essentially like a header for a door or a window, but it's made of thinner metal, not thin metal, but thinner than a 2x4. The minimum bearing length of each end of the lintel is 4 inches. So that means it should extend 4 inches or more past the end of the opening. Sorry. Firebox side and rear walls. The size of the fireplace is based on the size of the room. Most fireplaces are sized large enough to get a 2-foot long piece of firewood in there. With a few design exceptions, the firebox of a concrete or masonry fireplace should be about 20 inches deep. The space inside the masonry fireplace is the combustion chamber or firebox. The firebox walls, which extend upward to the damper, could be made of solid masonry units, stone, and concrete. If there's a lining of fire brick or other approved lining material inside the firebox, it should be at least 2 inches thick. Behind the lining should be the back and side walls made of solid masonry. The total thickness should be 8 inches, including the back wall and side walls and the lining. The width of the mortar joints of the fire brick lining should not exceed 1/4 of an inch. And you can imagine why that might be, right? When you have a brick wall, it's the weakest part of that wall is the mortar joints. So the mortar joints should not be excessive because the mortar joints are going to be the things that break down first, and they're going to be the easiest place to allow that heat to move. And if you understand building science at all, you know that heat is going to move from a hotter place to a cooler place, very generally speaking. So if you've got this hot inside the firebox, broken mortar joints, that all that heat and smoke and gas is going to try to be escaping through there. And so you want to make sure that the mortar joints of the fire brick lining are not exceeding 1/4 of an inch. And feel free to take out a tape measure and snap a picture. The mortar is a special type of clay mortar used just for fireplace combustion chambers that can withstand excessive heat. It's a medium duty refractory mortar. If there's no lining inside the firebox, then the back and side walls should be at least 10 inches thick of solid masonry. Remember that this measurement is for masonry fireplaces and not factory built fireplaces, which we'll cover in the next section. The firebox walls are slanted to reflect that heat energy into the room. This angle of the walls is referred to as splay. Splay slope is usually 5 inches per foot, so 5 and 12. The sloped walls help direct smoke into the throat of the fireplace. This photo above shows where the mortar joints of the fire brick are very large. There's a lot of cracking in the lining, particularly at the joints. Now, the fireplace throat and damper. The throat of the fireplace is located above the combustion chamber. It controls it controls the efficiency of the fireplace. The rising smoke passes through the throat and enters the front side of the smoke chamber. Manually operated dampers can be installed only in connectors or chimneys serving solid fuel burning fireplaces or stoves. And we'll talk a little bit later about retrofits and what the damper should look like when you have those situations. The damper is located above the fire and is used to control the combustion and prevent conditioned room air from escaping the flue. The damper must be made of a ferrous material. The damper must be operable from the room containing the fireplace. When there is smoke rising through the throat opening above the combustion chamber, the open damper is designed to control the downdraft. When hot gases and smoke rise up through the throat, they pass up into the front side of the smoke chamber. The rapid upward movement of gases creates a downward draft on the rear side of the smoke chamber. One purpose of the open damper door is to direct the downdraft back up into the smoke chamber and prevent it from pushing smoke into the room. So you can kind of see it a little bit better here. You've got your fireplace smoke shelf and chamber. The smoke shelf is located behind the damper. It helps open the damper, it helps the open damper change the direction of that downdraft we were just talking about. A fireplace works well if the smoke shelf is deep, and some smoke shelves are even curved. The smoke chamber is located between the top of the throat to the bottom of the flue. Smoke would enter the room without a smoke chamber. Its size is large enough to hold a lot of smoke. The interior surfaces of the smoke chamber are usually sloped and coated with a half-inch thick layer of cement mortar. Fireplace ash dump and clean out. Let's take a look at that. 2013 InterNACHI illustration. An ash dump is not required for every fireplace, despite the thinking of some. It depends on the type of fireplace and foundation. Cleaning of the fireplace may be possible from the fireplace opening if it lacks an ash dump. That reminds me of a question that we just saw a minute ago. And the easy answer to your anonymous question is no, I would not go sweeping ashes out of anywhere to check anything. I would disclaim it in the report. The ash dump is usually located in the rear hearth if there is an ash pit constructed below the fireplace. The ash dump is essentially an opening near the rear hearth through which ash and debris are passed. The ash dump is a pivoting metal door installed on a metal frame. It's usually made of cast iron. The homeowner generally cleans the fireplace by sweeping the cold ashes into the ash dump. They fall downward and end up in the ash pit, and that has to have a clean out door. As you can imagine, you don't just keep pushing ash into a big cast iron chamber. If the house has slab on grade foundation, the ash pit might not be quite as deep, but it would still require a clean out of some type, usually access from the exterior. This design of having the fireplace clean out door accessible from the exterior may be used when the fireplace is located on an outside wall. For slab on grade foundations, a raised hearth will provide enough space for an ash pit under the fireplace. The clean out door would have to be elevated high enough above grade in cold weather climates to help prevent the door from being blocked by snow. The cleanout for an ash dump must be made of a ferrous material or a masonry door and frame built to stay tightly closed. And access for the cleanout door should be provided and made readily available so that the removal of ashes do not create a hazard. And that should essentially go without saying. So let's talk about the cleanout. The masonry chimney cleanout. It's different from an ash dump cleanout. A masonry chimney cleanout is used to inspect, access, and clean the flue of a masonry chimney. Photos from an inspection of a masonry chimney cleanout are right here. This cleanout was open and debris was observed through the cleanout. Additionally, the upper edge of the cleanout was not at least 6 inches from the inlet. Corrections and further evaluations were needed. A cleanout is not required if the masonry chimney is used for a fireplace where cleaning is possible through the fireplace's opening. An example of a required cleanout would be if a home had an oil-fired heating system that was connected to a masonry chimney. A photo of a masonry chimney cleanout for a fireplace shows an open cleanout door for the ash dump. The ashes have already been cleaned out. Looks nice and neat in there. A clean out for a masonry chimney should be made of non-combustible material, which again, hope goes without saying. The clean out for an clean out opening for a masonry chimney must be located within 6 inches of the base of the flue. The upper edge of the clean out should be at least 6 inches below the lowest inlet opening. And the clean out opening should be at least 6 inches in height. Exterior air flue size and glass doors. Factory built and masonry fireplaces must be provided with an exterior air supply to assure proper fuel combustion unless the room is mechanically ventilated. The exterior air intake must supply all of the combustion air from the exterior of the dwelling or from spaces within the dwelling ventilated with outside air, such as a ventilated crawl space or a ventilated attic space. The exterior air intake must not be located within the garage or basement of the house. Cross-sectional area of a chimney flue is based on the area of the fireplace opening. One rule of thumb is that the flue area should be at least 1/10 of the total fireplace opening. A glass door enclosure may be installed at a fireplace opening. The enclosure helps lessen the amount of heated room air that escapes up the chimney. The rate of combustion can be controlled with the glass doors and by adjusting the damper and draft vents that may also be installed. So here we have a factory built prefab fireplace. Those are found in many homes because they're less expensive to install than masonry fireplaces, and they come in a wide range of styles. I'm sure you guys have seen them. Some factory built fireplaces have zero clearance requirements to combustibles, which means the house's wooden framing can come into contact with the fireplace's components, which again, the less regulation needed, the better in terms of perception. So these are fairly common in my area for sure. Factory built fireplaces operate in the same way that masonry fireplaces do. They share the same components. Room air can enter a factory built fireplace at the bottom of the unit near the floor and wrap around the firebox through the chambers. As the air is heated through the firebox, it flows upward because hot air rises. At the top of the factory built fireplace, air registers allow the warm circulating air to exit and enter the room. Some fireplaces are equipped with circulating fans. Factory-built fireplaces do not require concrete foundations. Although most factory-built fireplaces are metal, pre-manufactured, modular masonry fireplaces are also available. These masonry models incorporate special engineering techniques, including venting systems. Factory-built chimney should be installed according to the manufacturer's instructions, as you might imagine. All prefab chimneys must have a label from an approved agency that states the type of appliance with which the chimney was tested for use, a reference to the manufacturer's instructions, and the minimum clearance to combustibles. The manufacturer's instructions should contain every aspect of the installation of the chimney, including component assembly, clearances, supports, terminations, fire blocking or fire stops, and connections. So again, just to camp out there for a second, we touched on it earlier. If something's available for you to read, I would read it. And you might think, well, man, how many inspections do you want me to do a week and be reading a bunch of manufacturer's installation instructions and all these details that the manufacturers have? I mean, I'm a North Carolina inspector now anyway, and there's a lot of cookie cutter homes. There's a lot of like developments that it's the same builder and they're putting up 50 houses. So if they're using a particular product, they're probably going to use that product everywhere they build. And so it's good to read those manufacturer's instructions. It's good to see all the different ways, the different things that they're approved for. Because again, when you see something wrong, one thing that I hope you guys have learned as home inspectors is that it's not always about seeing what's wrong. It's about seeing something that's not right, right? So you're not required by any law or rule to be able to recognize every single defect that could ever possibly be. The easier approach is try to get familiar with the right way to do things, especially when it comes to certain types of factory built items where they have these manufacturer specs. At least look a few of them over, and a lot of these things are going to be similar from one to the next. So it's not going to be so deviant from one to the next where it's like, well, you know that one, but there's also this one. When you have factory built items like chimneys and different, fireplace inserts and things like that, check the manufacturer's instructions, read up a little bit, do a little bit of research and see if you can come up with, the right way that something needs to be done. That way, if something's done incorrectly, then you kind of call that out as a red flag. It's just like finding counterfeit money, right? If you talk to a counterfeit expert and you say, how do you know every counterfeit? Well, they're not going to say, I know every counterfeit. They're just going to say, I know the right one so very well that I know anything that's not right. And that's kind of how we have to function, is try to gather information on the right way that these things should be done. That way you can start to recognize defects when they're not done correctly, not because you know how to recognize every defect, but because you know the right way. And now the wrong way becomes very apparent to you. So factory built chimneys require no masonry construction. They're made of double or triple walled sections of metal pipe. Flanges and fittings are used to secure the fireplace and flue to the house's framing. Spacers provide proper clearances from combustible materials. The top of the factory built chimney has a storm collar to divert rainwater from the chimney pipe to the chimney flashing. A chimney cap must be installed on top of the flue pipe, to answer that earlier question. And if a factory built chimney is used with a solid fuel burner or an appliance with corrosive gases, the inside flue pipe should be made of stainless steel or have a porcelain coated surface. Chimneys for factory built fireplaces require specific clearances and support components. The openings through the ceiling and the roof should be carefully sized and constructed to provide the proper clearances. The openings through which the chimney passes should be blocked with fire stop spacers and support boxes. If the factory-built fireplace is located on an exterior wall, a chase can be constructed around the chimney to contain and protect it. And that's a lot of times what you'll see, kind of like in this photo here. What you're looking at is not a chimney. What you're looking at is a chase. And so that chase is really just some kind of exterior sheathing material, proper clearance inside to that flue. So the exterior walls of the chase are typically sided with the same exterior covering material as the rest of the house. And again, if it's a mystery to you, if you've ever seen one collapse, which I have, and knocked a big hole in the roof, you can see it's just an additional structure that gets fastened kind of the same way everything else does. Panel walls. The refractory panel walls of a factory-built fireplace requirement, excuse me, with a factory-built, let me start the sentence over. The refractory panel walls of a factory-built fireplace require replacement if a nickel on its end can be inserted into a crack, or when the surface of the refractory panel has abraded more than a quarter-inch from the original surface. Replacement of the refractory panel should be completed by a qualified professional, obviously. Wood-burning stoves getting much more popular, and so you'll see them in older homes, and now you're definitely starting to see them in a lot of custom homes and a lot of newer homes. A wood-burning stove, also known as a wood stove, pellet stoves are getting real common too. But a wood-burning stove is a heating appliance made from iron or steel that's capable of burning wood fuel. Unlike a standard fireplace, a wood stove is typically contained entirely within the living space rather than inset in a wall. And like you can see here, it's sitting not in the middle of the room, but it's independent of any wall structure. Small stoves are suitable in single rooms, seasonal cottages, or small energy efficient homes. These models can also be used for zone heating in large rooms where supplemental heating is needed. And again, I'm in North Carolina. That's fairly common here because heat pumps are a very inefficient form of heating. They're usually using supplemental electric heat in addition to, reversing that refrigerant flow. But these little wood burning stoves, or like I said, pellet stoves, are becoming more and more common because you can burn some wood in a room, not have to run that electrical auxiliary heat, and you're not so worried if the upstairs gets a little cool, you and your wife are hanging out in the living room or what have you. So medium-sized stoves are appropriate for heating small houses or mid-sized homes that are intended to be energy efficient and as inexpensive as possible to maintain. Large stoves, which I'm not looking at here, are used in larger homes or older homes that leak air and are located in colder climate zones. And like I said, older homes or newer homes. Older homes, a lot of times they're not very energy efficient, and making them energy efficient has a whole list of issues as far as building science is concerned. So sometimes the best thing you can do is just put a good sized wood burning stove in there and try to supplement the heating system that way. To assure safe and efficient use of wood-burning stoves, inspectors can pass along the following tips to their clients. Never burn coal. Coal burns significantly hotter than wood, and that's going to pose a fire hazard. You don't know if a wood burning stove is really designed to handle the type of heat that coal can kick off. Burn materials that will emit toxic materials, right? Never burn materials that will emit toxic chemicals, such as wood that has been pressure treated or painted, colored paper, gift wrapping, plastic, plywood, particle board, or questionable wood from furniture. Again, I'll reference North Carolina again. If you drive in the right part of the country, you're going to smell some crazy things because people burn these things outside. Definitely don't use your wood burning stove as some kind of trash getter ritter of, however you want to word that. Don't start throwing gift wrapping and colored paper and pressure treated wood. These are all things that these stoves are not designed to handle. It's going to off gas into the home. Never burn wet wood. Generally speaking, it takes 6 months for cut stored wood to dry out and be ready for use in wood burning stoves. So again, homesteading is getting real popular. Everybody's freaking out about getting a farm and a bunch of chickens and all this stuff. And then they want to cut their own wood and start burning it. That's great. Cut it, store it under cover for 6 months, and then it'll be dry enough to cut. And you'll hear the difference when you knock it on something. There's a very hollow sound to dry enough wood that's dry enough to burn. Okay, never burn combustible liquids like kerosene, gasoline, alcohol, or other fluid or lighter fluid or anything like that. Don't be spraying lighter fluid into a wood burning stove. Never let small children play near a lit wood burning stove, right? Unlike standard fireplaces whose sides are mostly inaccessible, every side of this wood stove is accessible and every single side of it is capable of burning your flesh or your clothing. Never let the fire burn while the fire screen door is open, right? We don't want embers flying out of there and causing a house fire. Some more tips. You've got the don't do's. Now here's the do's. Always use a grate to hold the logs so that they can remain secured in the stove and the air can circulate adequately around them and keep that fire burning hot. Always keep the damper open while the stove is lit. Always dispose of ashes outdoors in a water-filled metal container, right? Why is that? Because a lot of people see the ashes, they think the fire is out, they're good to go. They scoop it into a plastic bucket melts and catches on fire, right? You want to fill up a metal container with some water, put the ashes in that water-filled metal container and dispose of them outdoors. Always check your smoke alarms to make sure they're working properly and periodically remove the stovepipe between the stove and the chimney so that it can be inspected for creosote. Homeowners may want to hire a professional to perform that service. So again, do it yourself or have somebody else do it. As I get older and my kids get older, I like having other people do as much stuff as possible because I'm busy building deck for my wife, and I have other things to do. So if I'm having a wood burning stove, I would like somebody else to disconnect the pipe and get their hands dirty with all the creosote. So speaking of which, efficiency and air pollutants. While federal and state governments crack down on vehicle and industrial emissions, they do relatively little to limit the harmful air pollution emitted from wood stoves. The problem is so bad that in many areas, the smoke from wood stoves is the largest contributor to local air pollution. Smoke from wood stoves can cause a variety of health ailments from asthma to cancer. What inspectors should do: verify compliance, right? Inspect for an EPA certification label, which indicates compliance with the 2020 emission standards. Confirm the model year of the stove. Units manufactured after May 15, 2020 must meet the updated standards. Educate your homeowner clients, right? Explain the benefits of upgrading to a compliant wood heating appliance. You can even list some of these statistics about the harmful effects of some of these wood stoves that have been manufactured prior to that 2020 regulation, especially if the current stove predates that regulation. Highlight the health and environmental risks of older non-compliant stoves, like I just said. Check for state or local restrictions. Some jurisdictions may actually require stricter standards or ban the use of older high emission stoves entirely, right? So a lot of these grandfathered in items, they're not going to apply to safety issues where people's lives are at risk. Okay. So don't just assume just because it's an old house and it's got an old stove that the local jurisdiction, right? Who's the authority here, right? The authority having jurisdiction, the AHJ, whatever county or jurisdiction you're in, they may have a different regulation for older higher emission stoves completely. and it may be even more so than that 2020 emission standard. So do your homework, make sure you're well educated on this stuff. Okay, so the US EPA revised its new source performance standards, the NSPS, for wood heating appliances. Again, May 15th, 2020 is when those latest rules took effect, and they apply to all new wood heating appliances sold or installed in the US. So the current emission limits for wood stoves, for cordwood, the emission rates are now limited to 2.5 grams of smoke per hour. For cribwood, emission rates must not exceed 2 grams per hour. Cordwood tested more closely resembles, sorry, cordwood testing more closely resembles real world use, while cribwood uses a standardized fuel configuration for testing. Pellet stoves, emissions must not exceed 2 grams per hour, aligning with the cribwood standards. And pellet stoves are considered one of the cleanest burning wood heated appliances, which is why a lot of people, it's still considered a wood heated appliance, and it's pretty efficient. It actually does a fantastic job of supplementing a heating system. So how does that compare to the older standards? The prior standards for wood stoves were 4.1 grams per hour for catalytic stoves and 7.5 grams per hour for non-catalytic stoves. So the 2020 revision significantly lowered those limits to 2 and 2.5 grams per hour, making older stoves non-compliant immediately unless grandfathered in on certain local regulations. So, like I say, sometimes something's grandfathered in, sometimes it's not. If you're performing inspections in a certain jurisdiction regularly, definitely do your homework on those regulations and see if that authority having jurisdiction has stricter standards than the grandfathered in methodology. If it matters to you, the Canadian standards for emissions in Canada, the CSA standard remains the primary guideline. Wood stoves must emit no more than 4.5 grams per hour of particulate matter. In Quebec, stricter regulations often align more closely with the EPA's 2020 limits. Municipal regulations. So a Quebec City bylaw enacted on April 19th in 2021 aims to reduce fine particle emissions from wood burning appliances. The key provisions include certification requirement. Okay, so by September 1st, 2026, all owners of wood burning appliances must have appliances certified according to the CSA or EPA standards. Emission limits for new installations after that same date in 2026, September 1st, they must meet the most recent certification standards with fine particle emission rates not exceeding 2.5 grams per hour for furnaces or boilers. The maximum emission rate is set at 0.065 grams per megajoule. Ban on non-certified fireplaces. Starting on January 1st, 2024, the installation of non-certified decorative or ambience fireplaces was prohibited unless purchased before that date, with a complete ban on their use effective September 1st, 2030. So then you'll be against the law if you're still using those. Current owners of solid fuel appliances must declare them or must have declared them by April 1st, 2024, or within 90 days following the installation or removal of the new appliance. So why do the stricter emissions standards matter? For air quality improvements, reducing particulate matter emission helps mitigate health issues like asthma and cardiovascular disease. Cleaner burning appliances reduce contributions to regional smog and fine particulate pollution. If you've ever flown into LA, you would know that that's a legitimate issue. That's for other reasons other than wood burning appliances, but it's not for this conversation. Environmental benefits, lower emissions means less impact on air quality and reduced greenhouse gases associated with incomplete combustion. And for consumer awareness, homeowners benefit from more efficient stoves that burn less wood and produce less ash and creosote, right? So it's a safety issue and it's an efficiency issue. Things that burn more efficient. That's why a lot in the Northeast, a lot of older oil-fired systems, boilers and stuff like that are being switched over to gas because efficiency does matter. You're paying a lot more for whenever something's inefficiently burning, you're paying for the whole fuel source and then only 80% or 88% of it's being used, whereas some of the more high efficiency units are going to be burning a lot more cleanly and actually saving you money. So summary there, the EPA's 2020 standards, all new wood stoves and pellet stoves must emit no more then 2.5 grams per hour for cordwood testing and 2 grams per hour for cribwood testing or for pellet stoves. And in Canada, the emission rates are capped at 4.5 grams an hour under CSA, except in Quebec, which enforces stricter standards in case you're planning on moving to Quebec. And a lot of you guys are in New York, so maybe you're thinking of moving up that way, or you got family there. Home inspectors should verify compliance with these standards, ensure that the stoves are properly labeled, and educate their homeowner clients about upgrading non-compliant appliances. So again, knowing that sometimes things are grandfathered in and sometimes they're not, knowing that there's a standard, what are you going to do if you run into a unit that does not have a tag on it, that does not have a label on it, right? You at least want to mention it. You're going to want to put some of this verbiage in your report and say, hey, these standards exist as of 2020. Your stove does not have a label on it, so I couldn't confirm whether or not it was compliant. Here's the fallout from not having a compliant unit, right? Your unit might be burning at 4.5 grams per hour, and so your emission rates are too high. It's not good for your health. It's not good for your money. Are you telling them what they need to do? No, you're just saying, listen, I couldn't confirm or deny the compliance with your particular unit. You may be grandfathered in, you may not be. Okay. And if you're familiar and you do your homework in your area, education is your best friend when it comes to retaining clients. You want to be the guy who has all the information, or the gal who has all the information. You want to know the jurisdiction you're working in. Are the units that are non-compliant grandfathered in if they were manufactured prior to 2024, or are we just in a jurisdiction that's actually quite stricter? Because again, a lot of these standards, building code, all these different things, you're looking at minimum standards. So the authority having jurisdiction can certainly exceed those, and you're going to want to know about that to educate the people you're working for. So catalytic and non-catalytic wood stoves. Wood stoves are designed to burn wood efficiently while minimizing emissions, which is ideal. Two primary technologies that are used in modern stoves to achieve this: catalytic combustion and non-catalytic combustion. Each has distinct features, maintenance requirements, and benefits that home inspectors should understand. So tips for you guys: check for proper use. Look for signs of improper fuel use, creosote buildup, discolored catalyst, and ensure owners understand that only seasoned wood should be used, like we just talked about. You're not going to want to burn new wood. It's wet. Doesn't burn efficiently, creates a lot of smoke, issues. Inspect the catalyst if possible. Check for blockages, warping, or other damage to the ceramic honeycomb. Verify whether the catalyst is still functional if the stove is older. Evaluate the baffle for non-catalytic stoves. Look for signs of cracking, sagging, or deterioration in the baffle. And again, if you don't know what these things are, look up new ones. Look up new ones to see what they look like. That way, you don't have to be able to tell if something's bad. You just know this is not good. Educate your homeowner clients. Like we said, your biggest benefit as a home inspector is the ability to educate other people. So all the education that you get from InterNACHI, all the education you get from elsewhere, it's worth nothing if you're not able to disseminate some of that information to the people that you're dealing with. You want to be able to educate the people that you're talking to so that they know that you're the expert in the room. Emphasize the importance of regular cleaning and proper operation to ensure efficiency and compliance with emission standards. All of my reports have maintenance schedules for a lot of the items that I find. Catalytic wood stoves. So how do they work? Catalytic wood stoves use a ceramic honeycomb catalyst coated with a reactive material, often platinum or palladium. The smoky exhaust from burning wood passes through the catalyst, where particulates and gases are burned at lower temperatures than in a standard fire. This process significantly reduces emissions and increases efficiency by extracting more heat from the same amount of fuel. So the key features are efficiency. They're very high efficiency because of thorough combustion of the particulates and the gases. They're good for long burn times. They maintain a steady heat output over really long periods of time, making them ideal for overnight use. And the lower emissions, right? They meet or exceed the most stringent emission standards, and they usually outperform the non-catalytic models in that regard. They're very low emission. The maintenance and the drawbacks. So you will have catalyst degradation, right? They'll degrade over time and typically last like 6 seasons if you maintain them correctly. And using inappropriate fuel like treated wood or wet wood or failing to clean the stove can lead to premature failure. and the cost, right? There's all these benefits. Catalytic stoves are definitely more expensive than non-catalytic ones. And maintenance. They require a regular cleaning of the catalyst to ensure proper airflow and operation. The catalyst will eventually need replacement, adding to the long-term costs. So the non-catalytic wood stoves, those rely on three design features to achieve clean combustion without the use of a catalyst. They preheat the combustion air. They're introduced from above the fire. The preheated air ensures complete combustion of gases and particulates. The firebox insulation retains heat, promoting high combustion temperatures for cleaner burns, and a large baffle directs air and gases through the firebox, creating a longer path for combustion and maintaining higher temperatures. The key features on the non-catalytic stoves, they lack a catalyst, so they're simpler to operate and maintain. They're usually lower cost up front, so they're usually cheaper to purchase than catalytic stoves. And the ease of use, there's just less components to monitor and to replace. You're not going to have catalytic breakdown if you don't have a catalyst. So maintenance and drawbacks. The baffle that's in there, which redirects those air and the air and those gases, will deteriorate over time to constant exposure to high temperatures. The baffles do need to be replaced periodically, though less frequently than catalytic components. Efficiency is a bit of a drawback because the non-catalytic stoves are typically less efficient than catalytic models, like we said, and the burn times are usually a little shorter, making them less ideal for overnight. The following telltale signs indicate that the fire in a wood-burning stove suffers from oxygen deprivation and incomplete combustion, which will increase the emission of particulates into the air. And if you guys already know about how carbon monoxide is created, it's incomplete combustion. So it emits dark, smelly smoke, right? An efficient stove will produce very little smoke. An inefficient burn is going to be very dark, very smelly. That's why we said burning wet wood. This is going to be case in point for wet wood. It's dark smoke. It's smelly smoke. It's very horrible. There's a smoky odor in the house. There's soot on the furniture. And if the stove is burning at less than 300 degrees Fahrenheit, a flue pipe mounted thermometer should read between 300 and 400. The flames will be dull and steady rather than bright and lively. To ensure efficiency, homeowners should follow these recommendations. Purchase a wood-burning stove listed by the UL, the Underwriter Laboratory. Stoves tested by the UL and other laboratories burn cleanly and efficiently. Burn only dry wood. I can't emphasize that enough. Burn dry wood. Wood that has a moisture content of less than 20% burns hotter and cleaner than freshly cut wood, which may contain half of its weight in water. Burn hardwoods like oak, hickory, and ash once the fire is started. Softwoods like pine, they ignite quicker. They're good fire starters. So again, you want that kindling to be little split up pine, but put some nice hardwood on top of that, and you'll get a nice long, hot burning fire. Make sure the stove is properly sized for the space. Stoves that are too large for their area burn inefficiently. And burn smaller wood pieces rather than big, large ones. Smaller pieces of wood have a large surface area, which allows them to burn hotter and cleaner. Which again, this isn't like fire burning class, but smaller kindling, get a couple decent sized logs on there, and then use some smaller pieces to keep that fire going and to keep those bigger pieces hotter. Sorry. Inspection process. The inspector should inspect the following: solid fuel burning appliances or fireplaces improperly located where gasoline or other flammable vapors or gases are present, any unused openings in the chimneys or flues. The lack of a smoke detector is a huge one. A smoke detector should be installed in the same room as the fireplace. And in that same vein, the lack of a carbon monoxide detector, that should be installed in the same room as the fireplace as well. And that's a huge one, right? That's the silent killer. That's the one everybody's scared of because it's legit. Incomplete combustion produces that carbon monoxide. You can't smell it. You can't see it. It's very dangerous. A combustible lintel above the fireplace opening, right? That's not good. A combustible material within 6 inches of the fireplace opening that projects out 1.5 inches or less from the face of the fireplace. Combustible material within 12 inches above a fireplace opening that projects more than 1.5 inches from the face of the fireplace. A throat or damper located less than 8 inches above the fireplace opening. A manually operated damper that does not operate or close properly. And again, it says the inspector, in our standards of practice, the inspector shall manually operate any manually operable dampers. So if that does not operate properly, that's something that you've got to inspect and report. A damper or damper component that has rust or corrosion. The inspector should inspect for hearths that are not made of concrete or masonry and that have a thickness of less than 4 inches. Either one of those items would be a defect. If the hearth is made of anything other than concrete or masonry, and if it's less than 4 inches thick, that's a defect. The inspector should inspect for hearth extensions that have a thickness of less than 2 inches, that are less than 16 inches in front or less than 8 inches beyond each side of a fireplace opening. So they should be 6 square feet or more. Or they should be greater than 6 square feet. Excuse me, 6 square feet or less is a defect. And are less than 20 inches in front or less than 12 inches beyond each side of the fireplace opening that's greater than 6 square feet. So the inspector should inspect hearths, hearth extensions, and chambers for joint separation, damage, and deterioration. So let's move on to the inspection of single wall metal chimneys. The inspector should inspect for exposed interior single wall metal chimneys that are not continuously enclosed, where they extend through closets, storage areas, or habitable spaces where the surface of the chimney could come into contact with people or combustible materials. The inspector should inspect for interior single wall metal chimneys for distances that are less than 18 inches away from wood frame walls or any other combustible material, sized 18 inches or under in diameter that are less than 2 inches away from non-combustible walls, and sized more than 18 inches in diameter that are less than 4 inches away from non-combustible walls. And again, non-combustible wall, drywall. The inspector should inspect for distances between exterior mounted single wall metal chimneys that are less than 2 feet away from doors, windows, or walkways, that are less than 18 inches away from wood frame walls or combustible materials, sized 18 inches or under in diameter that are less than 2 inches away from non-combustible walls, and sized over 18 inches in diameter that are less than 4 inches away from non-combustible walls. Bigger pipe, more heat, need more clearance. The inspector should inspect for missing thimbles where chimneys are passing through combustible roofs, which, like I said, 80% of your residential roofs are going to be made of wood decking and asphalt shingles. These are combustible. The inspector should inspect for chimneys that terminate less than 3 feet above the highest point where they pass through the roof surface, 2 feet above any portion of a building within 10 feet, 3 feet from adjacent buildings or building openings, or 10 feet above grade or walkways. The inspector should inspect for chimney outlets that jeopardize people's safety, overheat combustible structures, or that might cause flue gases to enter nearby building openings, right? That's why the 3-2-10 rule exists, and the 2-2-10 for type B and type L. The inspector should inspect the crowns of masonry chimneys for slopes that direct water into flues. That's very suboptimal. So here's a chart of the liners, flues, and sizing. The inspector should inspect for galvanized flues and connectors. Flues and connectors should not be galvanized, very rusty. Inspect readily accessible and visible flues for rust and corrosion. Inspect masonry chimneys that are not lined. All masonry chimneys should be lined. If you have a masonry chimney, there should be a liner inside. If there's not one, that's where you're going to run into an issue where all you're relying on as far as the escape of embers, heat, gas, is the mortar joints. And those are not reliable long-term, and they're very difficult to repoint from the inside. So they need to have a liner. Inspect for linings that don't extend above the cap of the chimney, a level of 4 inches or more. Inspect for liners that are visibly softened, cracked, deteriorated, or damaged. Inspect readily accessible and visible flues and liners for excessive accumulation of creosote, soot, or other combustible material. Inspect for flues that have 2 or more openings at the same level, and inspect for venting into the space around and between the chimney liners. The remaining space surrounding a chimney liner should not be used as a vent. The inspector should inspect the size of the flue if visible and compare it to the size of the fireplace opening. This relationship is the most important factor in achieving sufficient draft A flue that's too small relative to the fireplace opening will be unable to lift and remove hazardous flue gases to the outside. So you need to have a flue that's the appropriate size to be able to handle what's burning inside that fireplace. Chimney and vent connectors. The inspector should inspect for connections from solid fuel burning appliances that have a rise to the chimney of less than 1/4 inch per foot. They're going to call that out as a defect. The inspector should inspect for connectors that are not as short or straight as possible. So again, if you see any reason why something could have been done differently, especially with bends in the pipes, I suppose with the installation of something, it's a little difficult to identify when something's not as short as possible, but as straight as possible. I've definitely seen some unnecessary bends to work their way around and stuff like that. So you want to call that out. You're going to look for connectors that are covered with insulation and of natural draft appliances connected to the positive pressure side of a mechanical draft system. The inspector should inspect for the improper installation of large connector pipes entering a flue above smaller connector pipes. The smaller appliance vent connector should connect to the chimney above the larger one. If there are 2 or more vent connectors entering a common gas vent, chimney flue, or single wall metal pipe, the smaller vent connector pipe must enter the vent, flue, or pipe at the highest point allowed. If there are 2 or more vent connector pipes entering one chimney flue or vent, the pipe penetrations must be at different levels, or the connectors must be installed at an angle of 45 degrees or less relative to the vertical. Vent connectors for Category 1 appliances should not be connected to any vent connector pipe of a mechanical draft system operating under positive static pressure. Below or shown is an illustration of 2 appliances and their vent connectors entering the same chimney flue. The smaller vent connector pipe is higher than the larger one. Cleanouts. The inspector, you should inspect cleanouts for doors and frames that are not made of ferrous material. And when it says the inspector should inspect, it means these are things that you're trying to identify, just for if that wasn't clear to anybody. You should inspect cleanouts for doors and frames that are not made of ferrous material, precast cement, or other non-combustible material. So again, if you see a cleanout door that's made of wood, major problem. It's a fire waiting to happen. Inspect combustible materials projecting beyond the faces of chimneys that are within 18 inches of cleanout openings. You should inspect for combustible materials stored within 18 inches of cleanout doors. Inspect cleanout doors that are obstructed or do not close tightly. Inspect the interior cleanout's lower edge for heights above the lowest accessible floor level that are less than 16 inches. Inspect the exterior cleanout's lower edge for heights above grade that are less than 16 inches. And inspect the bases of the fireplace chimney flues for distances that are not between 6 and 12 inches below the bottom edges of the cleanout openings. Now, like we were talking about before, whether the chimney is active, whether it's inactive, you want to help prevent chimney collapse. They're the heaviest and most structurally vulnerable of all the exterior components. Why is that? Well, because they're made of very heavy materials, and like we established earlier, they're not designed to be integrated into the structural capacity of the home. The chimney should not be relying on the home, and the home should not be relying on the chimney. So the chimney, we don't want it structurally connected in terms of the same footing. So the chimney's got its own footing, and so in one sense, it's freestanding. It's connected to the home, but not in such an integral way that it's actually a structural feature of the home. So this is a huge problem when it comes to chimneys pulling away and falling off. We get why we don't, it would probably happen more often if we integrated them tighter into the structure of the home, but a collapse can really cause some structural damage to the building and its surroundings. So inspection, maintenance, and preparedness are critical safeguards against chimney collapse. Wind and other elements may cause an already weakened chimney to collapse. There's one story of an elderly man in Britain that was crushed by a wind-toppled chimney because it fell from the roof of the managed care facility where he lived. That case is unfortunately fairly unremarkable, as those accidents can occur often for a variety of reasons, from weathering and wind, falling tree limbs, and just a poor design, poor installation. Chimneys collapse by the hundreds during major earthquakes, typically snapping at the roof line. More than half of the homes in Washington state expected by FEMA following the Nisqually earthquake in 2001 sustained chimney damage. Chimney collapses were widely reported following the massive 7.1 earthquake that struck New Zealand in September 2010. These are just a couple examples, right? So earthquake damages and injuries can be caused in large part by bricks and stones as they fall from chimneys onto vehicles, structures, and people. Those collapses happen suddenly and without warning. It's not like a tree branch that breaks and makes this big noise and then you've got warning. These things just pop off, they fall off, and they're moving by the time they hit either you or the ground. So the collapses can also cause implosion type destruction as the chimney makes its way through the roof and attic. I saw this during Helene down in South Carolina on some inspections that I was doing, where a tree fell and hit a roof, hit the chimney, and the largest masonry part of the cap fell through the roof and was caught on the in between the base of two trusses before it actually broke all the way through into the foyer. For those reasons, it's crucial that chimneys, especially in seismically active regions and for hurricane-prone regions, be inspected periodically for signs of weakening. Following an earthquake, it's even more vital that chimneys be inspected for indications of imminent or future collapse. Because again, those mortar joints are the weak spots. If you have some seismic activity, or in the case of a tree fall, if you have a tree fall that doesn't knock the cap off into the main living space, if it gets hit, those mortar joints are going to show signs of stress. They're going to show signs of deterioration a little bit prematurely, and you're going to see some separation between the bricks and those mortar joints, and those things are rife for then falling off in an otherwise non-catastrophic situation that becomes a catastrophic situation because that chimney has been weakened by some previous event. So chimneys should be inspected for the following defects. Mortar between the bricks or stones that crumbles when poked with a screwdriver. So hopefully you guys have a probe with you, a long screwdriver, maybe even just a little seam tester for commercial roofs, something that's hard and metal. Again, you don't want to go stabbing at it or hammering something in there, but poke at it a little bit, see if that mortar crumbles like sand while you're touching it. Missing or insufficient lateral support, such as steel straps used to tie the chimney to the structure at the roof and floor levels. Building codes in seismically active regions require internal and external bracing of the chimney to the structure for obvious reasons that we just talked about. Look for mechanical damage to the chimney, such as that caused by falling tree limbs or scaffolding. Visible tilting or separation from the building, like you're starting to see in this inspection photo, right? Any gap should be frequently measured to monitor whether it's increasing, right? That's true for structural inspections. It's true for this masonry chimney situation. If there is a crack, if nobody's brought it up before and you're bringing it up in your report for the first time, I would recommend there's even things that you can stick onto that wall that are crack monitors that you can take pictures of them like quarterly or once a week or however often you want to do it, that will actually visibly show you, hey, this crack's getting a lot bigger, or this is like a settling crack and there's nothing to write home about. You as the inspector, if you run into this on a home with that stucco finish is cracked wide open pretty much, there's definitely something that I would want to call out. I wouldn't leave that alone. And they might tell you, hey, that crack's been there for 10 years, but frankly, without a monitoring maintenance program in place, there's no way to tell how long that crack's been there. Because obviously, if someone's looking to sell the house, I wish it weren't so, but they may not be that willing to tell you, sheesh, that thing's brand new. I barely noticed it. And we just had a tree hit it a few weeks ago. We had the guys clean the branches off, nothing to write home about. But you guys are inspectors. You're looking for everything, right? Homeowners aren't looking for everything. So settling cracks, things like that, people might not be paying attention. And if there was some kind of an event, maybe that's the last thing they're looking for. So look for chimney footing defects, including undersized footings, which is a footing cast so thin that it breaks or doesn't sufficiently extend past the chimney's base to support its weight, right? You have what's called a tributary area under any vertical load, under any gravity load, right? A dead load. There's a tributary area, and you want to disperse that downward pressure by having a footing that's larger than the base of the chimney itself. Look for a deteriorated footing caused by weathering, frost, loose or poor quality construction. And poor soil below the footing, including eroded, settled, or otherwise weakened soil, frost heaving, or expansive clay beneath the footing. And that's one thing. The regulation, the standard is such that the footing should be poured on undisturbed earth because Mother Nature's pretty good at settling ground. So once you disturb that ground, it's really hard to get it back compacted the way that it was prior. So look for loose soil beneath the footing if you can see it. A more thorough inspection performed to the International Phase 1 standards of practice for inspecting fireplace and chimneys may also be considered. You may want to advise your homeowner clients to take these additional precautions. Attach plywood panels to the roof or above the ceiling joist to act as a barrier between the falling masonry and the roof, right? So you can actually, on the underside of the joist, install some plywood, some extra stuff that if that masonry falls and hits the roof, if it goes breaking through, you'll have one extra layer of protection. Strengthen the chimney, the existing chimney by repairing the weak areas. Tear down the chimney and replace it with a flue or stronger chimney. And keep in mind that tall, slender masonry chimneys are the most vulnerable to earthquakes, weathering, and other forms of wear. However, even newer reinforced or metal flue chimneys can retain significant damage and require repair. So there's no perfect world when you have a very tall, slender structure attached to your home. Instruct family members to get away from chimneys during earthquakes. Again, there are certain things in this training I hope go without saying, but maybe it's worth saying. If there is any seismic activity going on, I would probably not be outside anyway, but if I was, I would not stand near the chimney. So homeowners should contact their local building departments to obtain required permits before they start any significant construction that may affect the chimney structure or its supports. In addition to collapse hazards, leaning chimneys can also make using the fireplace dangerous. Hearth cracks, side cracks in the fireplace, openings around the fireplace, and chimney damage all present the risk that sparks or smoke will enter the living space or building cavities. Check for evidence of fireplace movement. Following an earthquake, homeowners should have their chimney inspected before using the fireplace. Commercial chimney collapses are rare, but they deserve mention due to the devastation they cause. In one terrible incident in central India, more than 100 workers were killed when a 900-foot tall chimney collapsed on a construction site. It's one of the worst construction disasters in any recent history, and the collapse was blamed on heavy rain. So while the safety standards are generally more stringent outside of India, commercial chimneys everywhere require inspection. So in summary, chimneys should be inspected to prevent expensive and potentially deadly collapses. All right. Water damage, chimney deterioration due to condensation. All masonry and factory-built fireplaces and chimneys can be adversely affected by direct contact with water. All chimneys can deteriorate from prolonged contact with water, right? Masonry materials deteriorate quickly when exposed to the freeze-thaw process, during which moisture that has penetrated the materials periodically freezes and expands, causing undue stress. Water can also rust in steel and cast iron. Right? So you're dealing with a couple issues there. Lintels that are exposed that are steel can rust. And then if you're dealing with masonry, it can deteriorate due to water. And masonry is semi-porous, right? Like concrete, brick mortar, all these things, they're not like if you pour water on the side of them, it's not just going to pour right through. But if it's hydrostatic pressure, it's vapor diffusion, whatever you're looking at, water can move through those items, and if it freezes and thaws, it's going to expand, cause undue stress, and when it contracts, it'll relieve that pressure and then cause things to spall a little bit. So inspectors should check for efflorescence. If you guys haven't seen that before, that bottom right photo is pretty thick efflorescence, and you usually see it in basements and places like that, especially basements that are below grade. You'll have hydrostatic pressure kind of pushing that water through, and then the minerals that are in the water deposit as the water dries. So the water actually makes it all the way through to the surface of the wall, and then the mineral deposits stay there when the water dries up. So look for rusted dampers, deteriorated masonry, rusted or corroded metal, wood rot at framing, water stains, clogged cleanouts, cracked flue lining, like we talked about, deteriorated mortar joints. Look for that stuff. And water damaged mortar joints, right? It can easily penetrate deteriorated mortar joints on the chimneys. So those can appear cracked, weathered, and have loose chunks of material. And a common repair for those mortar joints is called repointing, where the existing mortar joint is cut out and it's repacked with new mortar. And it's not necessarily cut all the way out. Anything that's deteriorating, you kind of scrape it away and repoint it. Installing a cricket to stop or prevent leaks is a good repair method, right? If the chimney is located on the low side of a roof where water runoff is directed against it, the installation of a chimney cricket will afford additional protection against water leaking into the home. And even if it's more than 30 inches, it's required. Even if it's less than 30 inches, it's still never good to have like a water dam on your roof. And like we talked about with the efflorescence, it's this chalky white powder. It's a cosmetic issue. It's not really a problem in and of itself. If you see that white chalkiness on the face of a masonry structure, the presence of the efflorescence isn't necessarily an issue. It's just that the presence of efflorescence represents a potential moisture issue. If there's a lot of efflorescence, that means there's a lot of moisture getting in. And there could just be a lot of efflorescence because it's a very old masonry structure, like the inside of a basement that's a very old house. Not a lot of people look at it. They don't care about the efflorescence on the wall. So that heavy buildup could be because of a lot of water, but it also matters how quickly that water has gotten in to produce that big of an amount of efflorescence. Here are a few tips that you can offer your clients so that you can understand the difference. Pinch between the fingers. Efflorescence will turn into a powder, mold will not. And so if you're looking at efflorescence and you're going, man, that is white and it's all over the wall, I don't know what it is. Efflorescence turns into a powder when you rub it between your fingers, preferably with a glove on. Mold will not turn into a powder. That's just going to kind of get all over your fingers when you do it. Efflorescence forms on inorganic building materials. Mold usually forms on organic substances. It's possible for mold to consume dirt on the brick or the cement, but if it's very clean brick or cement, you're not going to get mold growing on there. It's got nothing to eat. Efflorescence will dissolve in water, mold will not. So if you want to go so far as to bring a glass of water and look at that, the efflorescence will dissolve because that's where it came from to begin with. It was already dissolved in water, and you're just reversing that process. Efflorescence is almost always white, yellow, or brown, while mold can be any color you can imagine. Purple, green, yellow, I've seen it all. If the substance question is in purple, pink, or black, it's not efflorescence. Aside from mold, the following conditions can result from excess moisture in a residence: fungi that rot wood, water damage to sheetrock, and reduced effectiveness of insulation. Inspectors should note in your inspection report the presence of efflorescence because it generally occurs where there is excess moisture, a condition that also encourages mold growth. So again, to be clear, you're not saying efflorescence is a problem. You're saying efflorescence is the symptom of the issue that there's a lot of moisture intrusion. And does moisture intrusion affect the masonry wall where the efflorescence is? Not so much. Potentially at the mortar joints and such, we don't want excess moisture. But the bigger issue is if there's that much moisture getting in to leave that much efflorescence behind, it's going to potentially rot out some wood. It's going to potentially cause mold growth on some building materials that will allow that organic substance to build up. Prevention: an impregnating hydrophobic sealant can be applied to a surface to prevent the unwanted water intrusion. It will also prevent water from traveling to the surface from within. In cold climates, the sealant can cause material to break during freeze-thaw cycles. During a home inspection, bricks left out overnight should be kept on pallets and be covered. Moisture from damp soil and rain can be absorbed into the brick. If you've ever, if you wanted to do a little test at your house to say like how much water can brick absorb, leave them in a bucket of water, weigh them, leave them in a bucket of water overnight, weigh them again the next day. I don't know exactly what the figures will be, but it's going to be probably double its weight. Removal of efflorescence. You can use pressurized water to remove or dissolve the efflorescence. You can use diluted muriatic acid, which is basically, the shock that you put in your pool. Water should be applied first so the acid doesn't discolor the brick. Following the application, baking soda can be used to neutralize the acid and prevent any additional damage to the masonry. Muriatic acid is toxic, and contact with the skin or eyes should be avoided, and a strong brush can be used to simply scrub the efflorescence off, which again, it's a mineral deposit. It's not a huge deal, but if you want to get rid of it, there's a few ways. Just a note, the use of water to remove it may result in the reabsorption of crystals into the host material, and they may later reappear as more efflorescence, right? So if you remember what the process is, the water comes in, whether by hydrostatic pressure or just vapor diffusion or however it's coming in, it's building up on the surface and then it's drying off and leaving that mineral deposit behind. So if you use water to try and clean it off, what you might do is dissolve the efflorescence into the water, send it back into the masonry material, and then it just reappears a few weeks later or something like that. It's a cosmetic issue and it indicates a potential moisture problem. So you should know how capillary forces can cause structural damage to the building materials, and you should educate your clients about efflorescence and the potential problems that the moisture intrusion may cause. So porous building materials, bricks, concrete, wood, stone, they're all porous and they can absorb water and they can wick water using what's called capillary action. As water moves through the porous material, salts can be drawn in with it. Concrete, wood, brick, stone, and mortar are porous materials that contain salts. The ground that these materials can come into contact with also contains salts and minerals. Capillary action can literally suck water and transport it through porous building materials. So porous building materials are capable of wicking water for really large distances due to capillary action, really without a practical or a theoretical limit of capillary rise. 6 miles maybe is a theoretical limit, and that's literally just 6 miles directly up. Okay. So if you have a tree that can transport water from its roots all the way to its leaves, that's capillary action. It's a very powerful action. And when you add salt to that, it can be destructive. The salts dissolved by groundwater can be transported by capillary action through porous soil. Building materials in contact with the soil will naturally wick the water inward and upward. Like concrete footings, they're typically poured directly into soil without any capillary break. Sometimes that's called a rising damp, and that's the beginning of how water can wick upward into a structure. And when the capillary flow of water reaches the surface of a building material, evaporation occurs. As the water evaporates, salt is left behind, and that evaporation of capillary flow continues, and the salt concentration increases through the natural process of osmosis, which creates an imbalance. So nature hates imbalance. If you've learned nothing else, nature abhors imbalance and always wants to put things back into equilibrium. So to reestablish equilibrium through osmosis, water rushes towards the salt deposit to dilute the concentration. That rush of water creates massive hydrostatic pressures within the porous material, and those pressures definitely can be destructive. Those pressures from osmosis can create incredibly strong hydrostatic pressure that can exceed the strength of the building material itself. Okay, so a couple examples of how that pressure translates. Diffusion vapor pressure, 0.3 to 0.5 psi. Capillary pressure, 300 to 500 psi. Osmotic pressure, 3,000 to 5,000 psi. Okay, osmosis can create pressure that's greater than the structural strength of concrete, and that could be 2,000 to 3,000 psi. And with osmotic pressure, you're talking 3,000 to 5,000 psi. That's a huge amount of pressure. Those are incredible forces that would cause materials to flake, crack, and even break apart. Spalling. When efflorescence leads to strong osmotic pressures greater than the strength of the building material, the material can break apart, and the effect is called spalling. Hydrostatic pressure can cause spalling, but spalling can also be caused by freeze-thaw cycles in building materials that have a high moisture content. Both efflorescence and spalling can be prevented with capillary breaks, such as polyethylene sheeting under a concrete slab. Chimney kick-out flashing. This is probably one of the things that's like low-hanging fruit for home inspectors. I don't know how many times I've called out a missing kick-out flashing on a chimney, but it's a major, major issue. I'll tell you right now, if you're not already familiar, step flashing goes under the shingle, another shingle goes down on, so step flashing goes down, shingle goes down on top of that. Another piece of step flashing, another shingle. Another piece of step flashing, another shingle. The end of that step flashing is before the opening that's cut to allow for it. So the kick-out flashing is designed to take that water that's running down the wall, kick it into the gutter, and kick it away from the open hole in the wall. And If you guys do thermal, I would definitely recommend you go get infrared trained and use infrared. You can definitely see when there's a missing kickout flashing and it's rained recently, the whole inside of that big part of the wall right next to the gutter is going to show a thermal anomaly, which is probably moisture. Okay. So several factors can lead to rainwater intrusion, but a missing kickout flashing usually results in concentrated areas of water accumulation and usually severe damage to the interior walls. So you should make sure that kickouts are present where they're needed, and essentially they're needed whenever a wall extends past a roof to wall transition, right? So if there's a roof to wall area and the wall goes further than the roof, you're going to need a kickout flashing. So you may observe the following problems associated with the kickout. It was never installed, right? The need for kickout flashing was developed fairly recently, and the builder may not have been aware that one was required. The increased amount of insulation and building wrap used in modern construction makes buildings less breathable and more likely to sustain water damage. Kickout flashings prevent rainwater from being absorbed into the wall, making it more essential than ever. The following are locations where kickout flashing installation is critical. Like we just said, roof and exterior wall intersect. Where the wall continues past the lower edge of the roof and the gutter, kickout flashing is absent. Large amounts of water will miss the gutter, penetrate the siding, and get trapped inside the wall. Where gutters terminate at the side of a chimney, which is functionally the exact same thing as the roof to wall transition. If the kickout was improperly installed, the bottom seam of the flashing must be watertight. If it's not, water will leak through the seam and penetrate the cladding, and we'll have that same water issue. So again, if it's not watertight, it's almost no point to be there. The angle of the diverter should never be less than 110 degrees. Okay. If the kickout was modified by the homeowner, homeowners don't understand the importance of kickouts in a lot of instances, and they might choose to alter them because they're unsightly. So a common way this is done to shorten their height to less than the standard 6 inches. Some manufacturers are okay with 4 inches, but either way, you'll see homeowners trim them down and go, oh, not a big deal, I'll just cut it down. No bueno. Okay. They should be the same height as the sidewall flashing. Homeowners may also make kickout flashings less conspicuous by cutting them flush with the wall, and that makes them less effective also. Now, frankly, it's like a patch, so it does stop water from getting into a degree, but you really want it kicking the water away from the wall rather than just trying to block the wall. So kickout flashing should be present, should be properly installed if you're wanting to use it to divert rainwater away from the exterior roof covering material, and particularly at those chimney locations, which is why we're talking about it, because the side of a masonry chimney, the side, whatever siding the chimney has, it needs a kickout flashing the same way that a roof to wall would, right? So international phase 1 standards of practice. About these standards for inspecting fireplaces and chimneys, although this standard applies to both commercial and residential fireplaces and chimneys, it really exceeds the requirement of the InterNACHI Home Inspectors Standards of Practice and the International Standards of Practice for inspecting commercial properties. So again, InterNACHI standards, phase 1, even just phase 1, they have phase 1, phase 2, phase 3, even just phase 1, it really exceeds the SOP for InterNACHI. The purpose of this document is to establish international standards for the inspection of fireplaces and chimneys. This document also provides the universal fireplace and chimney inspection reporting language. So the goal of the inspection is to provide observations which may lead to the decrease of hazardous conditions associated with fireplaces and chimneys. It's an optional add-on home inspection service, right? It exceeds the international Association of Certified Home Inspectors standards of practice and the international standards of practice for inspecting commercial properties. They don't require you to perform a phase 1 fireplace and chimney inspection, but you can offer it in conjunction with a complete commercial or residential property inspection or as a separate standalone inspection service. Inspection frequency. You should advise your client that all fireplaces and chimneys should be inspected prior to their first use and not less than annually. Okay, that's a huge deal, not less than annually. So chimney flashing, we mentioned it earlier. This is brick, and this is the same thing as a roof to wall scenario. If Masonry wall to wood transition is going to function the same way as the side walls of the chimney flashing. The only difference is you wouldn't have a head flashing, right? So the illustration shows counter flashing installed correctly. It fits into grooves cut into the mortar joints. That's called a kerf, okay? Like a Nerf gun, N-E-R-F. It's K-E-R-F. It's a kerf. Some people call it a reglet line. No matter what you want to call it, there should be a cut that's made into ideally the mortar joint, but also sometimes just the face of the brick. What people are looking at, so I'll show you one other picture. Sometimes people will go, well, the step flashing on the chimney. And I'm like, what do you mean when you say step flashing? Because you can't see the step flashing, ideally. And they go, well, that flashing right there, it's stepped. That's counter flashing. Okay, just because it's formed like stair steps, that's not step flashing. The step flashing is the one that goes underneath the shingle and up the face of the sidewall, and then it gets covered with counter flashing. So again, to show you this detail, you can see the brick. You can see that there was a kerf or a reglet line cut for the top of that counter flashing to bend in. So the order of operations is cut the kerf, install the step flashing, then install the counter flashing bent at the top to fit into that brick. To fit into that kerf, the gaps in the brick, and then you put sealant over that. And that's going to be essentially watertight. What a lot of people end up doing, and it's hard to recognize when they do it if you're not up on it looking at it really closely, what they'll usually do is just press that counter flashing up against the brick, and they'll nail right through it with a masonry nail, and then they'll put sealant over top of that. That makes the sealant at the top. So the masonry nail is just holding the aluminum flashing in place, and then the sealant is the primary mode of water diversion, which sealant is not meant to last very long with full UV exposure. So in this configuration, you've got sealant that's acting in conjunction with a properly installed flashing. If they just press the flashing up against it, the sealant is going to fail very prematurely, and you're going to have water leaking issues. From this photo, you can see that counter flashing installed into the kerf lines and on the low side of the chimney. The apron flashing, which is basically a head wall, overlaps the shingle covering. So you can see that apron flashing is coming down like an apron. The head wall is up behind the chimney. And this chimney is less than 30 inches, so it doesn't look like it has a cricket. It's not needed as long as your head wall flashing is installed correctly. This cricket has heavily applied roof sealant at the valley and ridge. That's a defect, okay? You want the materials to function as they're designed. Sometimes people have, they'll see that there's a leak and they'll just start caulking stuff. Well, in this instance, there's a California valley in between the cricket and the main roof. So you've got a cut valley, which really wouldn't be ideal in that circumstance. But to their credit, the larger roof area is cut over the top and laid over the top of the smaller roof area. So theoretically, as long as it's all flashed properly, you shouldn't have a problem. Well, they did have a problem, and then someone caulked it. Adding a full line of caulking just functions as a water dam in these instances. You're more likely to make the leak worse. So that's not very good. You can see here, this chimney lacks counter flashing and has improperly installed step flashing. Both of those are defects, okay? No counter flashing, they just used step flashing and a caulking gun. We don't like that. And we saw this before. You're missing a kick-out flashing at the area where the gutter ends meet the chimney. That's not good. That's definitely a defect. You got a chimney with a loose storm collar, right? That's a defect. This chimney has a deteriorated rain cap. That's a defect because the whole purpose of the rain cap is to keep the rain out. There's literally a hole from rust in this. That's not good. This is an exterior fresh air intake for a prefabricated fireplace. So if you see a prefab fireplace, you should see one of these on the outside for that fresh air intake. Oops, sorry about that. I scrolled in the wrong spot. as you can see here, we've got a chair that's pretty darn close to that fireplace. Combustible materials should be located at least 3 feet away from the fireplace opening. And I recognize that's not permanently installed, so that's fine. But if that's where that chair normally is, so again, if you want to get really nerdy and be an inspector about it, move the chair 6 inches and see if there's an imprint in the floor. If there is, that probably means that that's where that chair is all the time. And I would call that out and tell them, listen, I know you like your right arm to be warm, but you're way too close to the fireplace. This photo shows a metal flue liner taken from below the damper. This one shows a factory built fireplace with some type of vent component for circulating warm air around the unit and into the room. This is a draft damper on the connector pipe from an oil-fired heating system to the masonry chimney. It's in close proximity to combustible materials, including the dryer's plastic vent pipe and the plywood attached to the wall. So we're going to call that out as a defect. The smaller diameter flue connector pipe from the gas-fired hot water tank is properly located and entering the masonry chimney above the larger diameter connector pipe from the heating system. However, you can kind of see the smaller pipe is loose and detached from the inlet opening, which is a hazardous condition. My dad was a heating and air guy up in Boston for many, many years. I've seen a lot of these pipes. I've seen a lot of this configuration. I know that if I pull on that a little bit, it will move. And so I might do that and take a photo of it. You do that at your own peril. If you pull that thing off and it falls down and dumps soot all over the basement, and who knows? Then somebody's going to be claiming that's their favorite part of the basement floor, and you just destroyed it. So do it at your own risk. But I would even take a little video and jiggle it. And depending on what inspection software you use, you can usually include a little video and say, "Hey, this." Great job connecting the smaller vent pipe above the bigger one, but it's loose. This is an open damper and flue pipe from a brand new unused prefab fireplace. You can see that is fresh off the line. That's gorgeous. Fireplaces, wood burning stoves, and their chimneys must be inspected and cleaned no less than annually, right? So at least once a year. This does not look like this has been well maintained. Some damper doors are located at the top of the chimney stack. The damper operation should be accessible and in the same room as the fireplace. So if you're disclaiming it as it's inaccessible to me in the same room with the fireplace, that in and of itself is a defect. This is a small handle for operating a manual damper in a prefab fireplace. So again, familiarize yourself with some of these things so that you know where to look. You don't want to be saying that you can't do something because, like I just said, that might work against you, because if you're saying, well, can't find the damper. Well, if you're a home inspector and you can't find the damper, that would probably be a problem for the person who's buying the home. So you should call it out as a defect if it's not accessible in the same room as the fireplace. This flue connector pipe is in very close proximity to combustible materials, which is a fire hazard. So again, it looks like these materials are movable, but they're just, again, they're living life. They're stacking stuff up against the wall, and it's all combustible material. Regardless of whether or not it's movable, you got to mention it. You got to call it out and tell them, yeah, it is movable, so move it so that it doesn't cause a fire. Creosote buildup was observed on the rear wall of this fireplace. Inspection and cleaning by a certified chimney sweep are needed. Okay, creosote is combustible. That's not good. You wouldn't put wood inside of a fireplace unless you wanted it to catch fire. So you don't want creosote inside of a flue unless you want it to catch fire. Mortar joints of this chimney are cracking into pieces, which is a defect. It's kind of a low res image, but you can tell on the inspector's hand is literally a flake of the mortar joint. And again, if you have any kind of like a hard probe that you'll use for decks or to check for rotting wood, you want to kind of poke at that a little bit and see if it's crumbling and falling apart. And again, take a video of yourself doing it. That way, you're not just saying it with a little flake of something in your hand. That's great for when we're taking pictures with digital camera, but inspections have moved far along enough that I would be including a few short videos here and there in your reports if you have the ability to do that. This is a deteriorated flue lining, which is a hazard. It's not a continuous piece, so it's sealed. So it's not cast in place. It's clay, and it's definitely deteriorated. It's looking pretty bad. So that's a hazard. That's a pretty serious defect. This is also a severely deteriorated flue lining. That's a defect. The chimney cap or the chimney crown or the chimney wash, whatever you're going to call it. This is deteriorated. You can pick up a piece, it's cracking, it's breaking away. It's actually growing moss in the middle of the cracks, which, like we talked about with freeze and thaw cycles, if you've got moss growing in between cracks, that's going to absorb water. If you're in a cold climate, that's going to freeze. Water is one of the only liquids that expands when it freezes. So if that's absorbing water, that water is going to expand when it freezes and push those cracks further and further away. And you can tell that this is an older thing. It's got organic growth kind of in the mortar joints and all kind of around. So this is the situation. So you want to call that out. The doors to wood stoves should operate as expected by the inspector and should close tightly with the latch. The rope around the door's interior makes for a nice tight seal. So kind of like weather stripping or something like that. You push this closed, you've got that rope around the door, that wire or metal rope. You push that closed, it'll make a nice tight seal. It shouldn't be like mega easy to latch that closed. It shouldn't be mega hard either, but it should be, you should feel some resistance when you're locking that down, and that means you've got a nice tight seal. This photo shows a chimney pipe and chase in an unfinished attic space, right? So you've got a chase built with plywood around it. And to that earlier question, I don't know if this is the type of black that you're seeing. That's an active roof leak. You can see it at the chimney flashing area as observed in the unfinished attic space. And again, try to use your best judgment. Water tends to wick. So in infrared thermography, we have this differentiation between different types of heat transfer. So when you're looking at conduction, you have a thermal gradient, whereas if you're looking at convection, you have wispy patterns. The same thing kind of applies here with water intrusion versus something coating this. If this is like a creosote buildup, or if this is soot because there's smoke escaping, it's going to look very different than this sort of wispiness of the capillary action happening because the water is getting wet. So you can see that there's water clearly coming in most severely at that corner, and then it's wicking away from the wall. So you see those kind of wispy patterns. That's very obviously a water damage issue. But you can see in this next photo, if that would look like this with much more clearly defined edges around that black, then yeah, it's probably some kind of a smoke damage, potentially a creosote buildup, who knows what. But either way, to that earlier question, black wood in an attic around a chimney is never a good thing. But if it looks like this, you're probably looking at water damage. The inspection photo here is showing that the walls of the prefab fireplace have large open cracks in the wall material. That's not good. A gas-fired decorative fireplace unit like this one can be installed in a traditional fireplace, but only according to the manufacturer's recommendations and instructions. So this is what they call a retrofit. You can see it looks like there's a natural gas, or it could be LP. I'm not sure. It might actually be LP. But either way, this was originally a actual fireplace, and this is an insert that's been retrofitted. Glass door enclosures should be inspected for damage, rust, attachment issues, cracked glass, and operation. So again, same way you would operate a damper. If you see these glass doors, pull that open. That's a double slide. It should just pull right out and slide to the side like an accordion door. Okay, so safe practices for fireplaces and wood stoves. More than 1/3 of Americans use fireplaces, wood stoves, and other fuel-fired appliances as the primary heat source of their home. Unfortunately, many people are unaware of the fire risks when heating with wood and solid fuels. Heating fires account for 36% of residential home fires in rural areas every single year. These fires are often due to creosote buildup in chimneys and stovepipes. All home heating systems require regular maintenance to function safely and efficiently. So again, like we said, not less than annually. You can do more than annually. You could do quarterly if you want to, but not less than annually. So the fireplace damper must be fully open before starting a fire and left open until the fire is completely out. Fireplaces should not be overloaded with firewood. Green or wet wood should never be used. Screens should be closed during the fireplace's operation to prevent sparks from flying out of the room. Glass door enclosures can be closed to reduce heat loss from the room to the chimney. Glass doors on a factory-built fireplace must be tested and listed for that particular fireplace. It can be dangerous to use the wrong set of glass doors, so they're not interchangeable. You have to use the correct one for the unit you're using. A wood stove, freestanding or insert style, should never be installed in a factory-built fireplace system unless the insert has been tested and listed for use. Annual chimney inspections and sweeping are recommended. Have your chimney or wood stove inspected and cleaned annually by a certified chimney specialist. Keep the area around the hearth clear of debris, decorations, and flammable materials, including chairs. Leave glass doors open while burning a fire. Leaving the doors open ensures that the fire receives enough air to complete combustion, and it keeps creosote from building up at the chimney. So usually those glass door systems will have glass doors that slide open, and then they'll have a screen behind them, and you can open that to manipulate the fire, but you close that screen, you leave the glass doors open. Close the glass doors when the fire is out to prevent air from the chimney opening from getting into the room or from your room to just bleed out the chimney. Most glass fire doors have a metal mesh screen, like I just mentioned, which will be closed when the glass doors are open. That's going to help keep embers from getting out of the fireplace area. Always use a metal mesh screen with fireplaces that do not have glass fireplace door. Install a stovepipe thermometer to help monitor the flue temperature. Keep air inlets on wood stoves open and never restrict air supply to a fireplace. Otherwise, creosote may build up, which could lead to a chimney fire. Use fire-resistant materials on the walls around a wood stove. Never use flammable liquids to start a fire. Don't use accelerants. Don't use lighter fluid. Only use seasoned hardwood. Soft, damp wood accelerates creosote buildup. And pellet stoves burn only dry, seasoned wood pellets. Build fires that are small, that burn completely and produce less smoke. Don't burn cardboard boxes or trash or other debris in your fireplace or wood stove. If you're in North Carolina, just do that in your burn barrel outside or whatever you want to do, but don't do it in your wood burning fireplace. When building a fire, place logs at the rear of the fireplace on an adequate supporting grate, letting the air move around them. Never leave a fire in the fireplace unattended. Extinguish a fire before going into the bed or leaving the house. Allow ashes to cool before disposing them. And again, putting them in that water-filled metal container is going to do you good, and then dispose of that stuff outside. Keep stacked firewood outdoors at least 30 feet away from your home. Keep the roof clear of leaves, pine needles, and other debris. Cover the chimney with a mesh screen spark arrestor. Extend all vent pipes at least 3 feet above the roof. Remove branches hanging above the chimney, flues, and vents. Install smoke alarms on every level of your home and inside and outside of each sleeping area. Test them monthly and change the batteries at least once a year. Consider installing the new long life smoke alarms. They've got the 10-year ones. Provide proper venting systems for all heating equipment. Remember, fire safety is a personal responsibility. That being said, fire extinguishers. Those are used to douse a fire and prevent its spread. Now, keep one thing in mind for me, okay? If you've ever seen one of these things, they're very small. You have a couple seconds worth of spray, and that's about it. Okay, so it's a small metal canister, contains compressed gas, usually nitrogen. Then when it's activated, it propels a direct spray of flame retardant chemical at the fire. Fire extinguishers are only effective if the building occupants understand where and why they're used. So again, it's really at the outset of a fire. If you see some small thing happening, get your fire extinguisher, hit it. If something's already roaring a little bit, you'd have just as much luck throwing the fire extinguisher at it if you wanted to, but just get out of there, please. These do not spray for very long. It's not like spraying a hose at something. It's like setting off a fire retardant explosion. Very quick, you spray it all out, and then it's like, if the fire's not out, beat feet, get out of there. Fire and extinguisher type, okay, class A. This extinguisher is used against fire that result from ordinary combustibles like wood and paper. B class extinguishers used against fires that result from combustible liquids like kerosene, gasoline, oil, and grease, otherwise called accelerants in a lot of instances. Class C is used against electrical fires, right? The combustion of circuit breakers, wires, outlets, other electrical devices. Extinguishers designed to handle this type of fire cannot use chemicals that are conductive, since conductive agents increase the risk of electrical shock to the operator. D class is used against fires that result from combustible materials like sodium, potassium, titanium, and magnesium. Those are mostly in chemical laboratories. They're pretty rare in the residential environment. And K class is used against fires that consume vegetable fats or animal fats, and they're used that generally for kitchen fires. So commercial kitchens are going to have those K class. You know, if you use one at your house, if you buy one at your house, you can get a class ABC at Lowe's or anything like that. Keep it under your sink. Again, you'd want a K class for a kitchen fire, but any normal combustible material ABC should do pretty good. No fire extinguisher can be safely or effectively used for every type of fire. Some contain chemicals that are ineffective in certain situations and can even cause harm to the operator if misapplied. To prevent confusion, extinguishers are classified by the type of chemical agents that they contain. So they have dry chemical. Those are one of two types of fire extinguishers that use a dry chemical. One's called a multi-purpose and uses ammonium phosphate as the extinguishing agent, which is effective on A, B, and C class fires. This chemical is corrosive, might be scrubbed from surfaces after use. These types of extinguishers are very common. They're usually in schools, houses, hospitals, offices. Sodium bicarbonate is used in extinguishers known as regular dry chemical, which are capable of handling B and C class fires. Those extinguishers are usually in garages, kitchens, and labs. Sodium bicarbonate is pretty easy to clean. It's non-toxic. Carbon dioxide extinguishers contain liquid CO2 and it comes out as a gas. They're effective against B and C class fires. Unlike other chemicals, CO2 doesn't leave a harmful residue. It's environmentally friendly and poses very little danger to the electronics. It's effectively employed in laboratories, computer rooms, and other areas with sensitive equipment. And then you've got water extinguishers that are most suited for A class fires. They can't be used in B, C, or D class fires, though. In B and D class fires, the water will spread the flames. In a C class fire, the water is conductive and it poses the risk of electrical shock to the operator. So if you're trying to put out an electrical fire with the water, you know, I'll let you do your imagination. However, the misting nozzle of a water mist extinguisher breaks up the stream of deionized water, so that there's no conductive path back to the operator. Since the agent used is water, those types of extinguishers are inexpensive and environmentally friendly. Wet chemical. So we have the dry chemical ones. The wet chemical ones are designed to combat class K fires and commonly use potassium acetate. They're appropriately employed in commercial kitchens and restaurants, especially around deep fryers. Chemicals emitted as a fine mist so that it doesn't cause the grease to splash onto the other surfaces. So it doesn't come out as a stream to splash the grease. It comes out as a really fine mist. And they can also be used in class A fires. So inspection of extinguishers. Again, we'll try to hit the gas here, but the InterNACHI inspector should check that a portable fire extinguisher exists within 30 feet travel distance of a commercial type cooking equipment that uses cooking oil or animal fat. Check that a portable fire extinguisher is within 75 feet of travel on every floor. Check for the presence of portable extinguishers and determine that they are located in conspicuous and readily available locations immediately available for use and not obscured from view. Confirm that access to extinguishers is not obstructed. Make sure that the hose, if so equipped, is intact and not obstructed. Make sure that the pressure dial reads green or charged. It should also be clear and readable. Check that the pull pin is securely fastened with the handle held in place by the anti-tamper seal. Check for visible dents or cracks in the extinguisher's canister. Check that the extinguisher is in proper location and mounted correctly. Check for modifications that might reduce the extinguisher's functionality, and make sure that the fire extinguisher has a label and that label is legible. Inspectors should not do the following. Please do not test a fire extinguisher. I know that we have insurance, but do you really want to call your insurance agent and say that you've destroyed something in a customer's house because you decided to test a fire extinguisher? Determine the adequate number of fire extinguishers needed or their ratings, okay? We talk about everything. We're going to teach you everything that we can teach you. If you want to talk about it, you can, but you're not required to talk about the number of fire extinguishers needed or their ratings. When you get out over your skis a little bit, when you start to think like, man, I got this InterNACHI course in, I got all this information, I want to hammer some people with it. Good for you, but don't step out of your lane. Stay in your lane. You don't need to talk about how many fire extinguishers are needed. However, if you want to put some kind of precautionary statement in there and say a portable fire extinguisher should be within 75 feet of travel on every floor, right? But if one floor has, if it's a 3-story house and one floor has got like an electric dryer and some other things, obviously it's important on that floor. Is it super important on the base floor? Well, yes, that's where the kitchen is. You know, do some math and think about it before you just start rifling off facts at people. But again, I just wouldn't recommend getting out of your lane and talking about the number of fire extinguishers, the rating of the fire extinguishers. Just check and see if they got some fire extinguishers that's better than a lot of people do. And you certainly don't need to ignite or extinguish fires. Okay. The National Fire Protection Agency recommends that extinguishers be tested every 5 or 12 years, depending on the type. The standard method of testing is conducted underwater, where the cylinders are subjected to hydrostatic pressure that exceeds their ratings. And vessels that fail the test are condemned and destroyed, while the rest are reassembled and put back into service. According to the NFPA, extinguishers should not be tested, but destroyed instead if any of the following conditions are present: evidence of repair by soldering, welding, brazing, or the use of patching compounds. The cylinder threads are worn, corroded, cracked, broken, or nicked. There's corrosion that's caused pitting, including pitting under a removable nameplate. Anything, if it looks like it's been burned. A calcium chloride type extinguisher agent was used in a stainless steel fire extinguisher. The shell is of copper or brass construction joined by soft solder or rivets. The depth of a dent exceeds 1/10 the greatest dimension of the dent if not in a weld, or exceeds 1/4 of an inch if the dent includes a weld. If it's dented, I would just report it. Any local or general corrosion, cuts, gouges, or dings have removed more than 10% of the minimum cylinder wall thickness. So I don't know how you would generate that without cutting it open and ruining it, but you know, if it looks like that to you, go ahead and report it. A fire extinguisher has been used for any purpose other than to extinguish a fire, like hammering a nail in a wall to hang a picture. When should a fire extinguisher be used? Small fires can be controlled through the use of a household or commercial fire extinguisher. A household extinguisher can completely douse a very small fire and prevent the need for professional assistance. Even if it can't be completely doused, a homeowner can potentially control a blaze with an extinguisher long enough for firefighters to arrive. A fire extinguisher should not be used if the operator is not sure if they have the proper type of extinguisher. So again, if you're not sure, you don't want to go spraying an extinguisher at something. Just let the professionals step in and handle it. What's on the label? Essential information about the types of fires that an extinguisher can combat, right? We know that. Numerical rating that designates the extinguishing potential for that particular model, Class A, Class B. Instructions for operation, and a tag that indicates if and when an inspection occurred. Do they expire? They do expire, and they do this for a few different reasons. A common way is that over time, the seal on the neck will weaken and allow compressed gas to escape. Extinguishers that have lost much of their pressure obviously won't operate properly. So the pressure within the extinguisher can be checked through a pressure gauge. ABC class extinguishers, ammonium phosphate extinguishers, have a tendency to fail due to solidification of the chemical inside the base. Okay. If an if an expiration date can't be trusted and there's no foolproof way to know if it's no longer functional, I would just replace it. Like if it's questionable, just replace it. So extinguishers are classified based on their chemical ingredients, all of which have known strengths and limitations. It's important to know which type of extinguisher you would use for what kind of fire. Have that thing around, right? The K type, if you're going to be working with a deep fryer. Fire extinguishers are critical indoor components that must be maintained and inspected regularly. Fireplaces and wood stoves are designed to burn only one type of fuel. Used as all-purpose incinerators, these devices can impose the following hazards. Harmful vapors can vent to the living space, harmful vapors to the outdoors, and you can cause mechanical damage, right? They can become lined with residue from inappropriate burning materials and might lead to a dangerous chimney fire. So what can be burned in a fireplace? Dried, cut firewood, right? Dried, cut hardwood. If you're going to cut down some hardwood, Should be stacked in an open area outdoors so the sun can warm the pieces and dry them out. Okay, less than 20% should be the moisture content of a roof, or sorry, of a piece of wood if before you burn it, then you can use your moisture meter to check that. The wood will darken from white or cream to yellow or gray. You'll have some cracks in the end grain and a hollow sound when you knock the two pieces of wood together. It won't be like a dull thud. It'll be a nice hollow sound. Okay, and you can split a piece if you're feeling manly that day. Okay, wood won't hiss while it's burning if it's correctly dried. And again, you can use your moisture meter to check that. Pallets are generally safe, although some of them are treated with methyl bromide, but you'll see those marked with the initials MB if they have the fumigant methyl bromide on them. Those are not safe to burn. So also, you never know what was stored on that pallet if they were exposed to a bunch of chemicals while they were being used, but other than that, if you have a pallet, it's usually a pretty dried wood and you can burn that. Fallen tree limbs, you can use them for kindling, but you want to give them time to dry. Housing development wood, if it's like trash and you're actually not stealing someone's property, right? Like a contractor, if you got scavenged like scrap wood that was used for framing, then yeah, it's usually been kiln dried and you're usually good to go. Fire logs, those are artificial logs that can burn relatively cleanly and release less ash than a real wood, so you could use those. What should never be burned? Painted wood, pressure treated wood, plywood, particle board, chipboard, OSB, all those are just like totally impregnated with glue. And so you're just basically burning a big piece of glue. Rotted or moldy wood, you don't want those spores to get in the air. If you have damp wood, it'll burn very inefficiently. And again, incomplete combustion, you can get that carbon monoxide. Dryer lint, trash, driftwood, all those things you should avoid burning in your fireplace. Ventless and unvented combustion appliances. It's recommended those not be installed within the conditioned space of the home. Unvented combustion appliances include unvented fireplaces, also known as ventless, vent-free, or ductless fireplaces. Gas, propane, or ethanol burning fireplaces, they don't have a vent, so they draw combustion air from the room they're in, and they release toxic combustion byproducts and moisture vapor back into the space in which they're located. Their use is actually banned in a lot of states and municipalities. For aesthetic reasons, builders will sometimes install the ventless that have real flames, providing the ambiance of traditional fireplace with the convenience and cost savings for the builder because they don't need to install a chimney. The manufacturers report they burn nearly 100% efficiency. However, because they're ventless, any unburned combustion byproducts are released into the living space because there's no chimney to vent them out, right? So due to safety and health, moisture concerns, a lot of building scientists recommend that unvented appliances not be installed in homes. Energy Star version 3.0 permits their installation, but requires that an inspector test the appliance using a portable CO monitoring device while the appliance is in operation. Okay. Can the health hazards of an unvented heater be reduced? Right. Yes, if you use only approved gas heaters with ODS pilots, follow the operation and maintenance instructions carefully, clean the burner yearly or even more often. Don't use an oversized heater. Don't operate for more than 4 hours at a time. Don't use unvented fuel-fired heaters in bedrooms, bathrooms, or any other confined space. Provide adequate ventilation. And if the pollutants cause health problems, definitely discontinue that use, obviously. Right? Ventilated fireplaces typically burn natural gas or propane and use a vent to bring outside combustion air directly into the firebox to support the fire. Those have tight-fitting glass doors across their face to prevent conditioned room air from being used as combustion air and then being expelled through the exhaust. Consuming room air for combustion may deplete the oxygen levels in the home. Heat still radiates into the room. Exhaust gases can be expelled vertically up a chimney or horizontally out a sidewall. Okay, so unvented combustion appliances should not be installed within the conditioned space of a home. Their use is banned in many states. It can be very, very dangerous. So I included a link at the end to watch this fireplace inspection with Mike and Nick if you want to. It's very informative. It's very good. One thing from that video that you want to look for in the video, they're looking at a chimney that has had the damper removed, so that would make it not usable for a solid fuel burning fireplace. So the damper clip is the preferred method because when you put a damper clip, it leaves the damper open for gas buildup. So if you're using a a gas fireplace or something like that, you want to clip the damper, and then you can still, if it's a retrofit, you can switch back to solid fuel burning at another time and unclip the damper if you want to. Couple things to look for. There are 3 levels or degrees of creosote buildup, right? Level 1, level 2, level 3. Level 3 is like a gemstone is formed in there. It's very hard. It's very difficult to deal with. And then on that crown, you can see pretty obviously you're going to have big problems with water entry. Okay. The number one cause of water entry into the chimney chase is a cracked chimney crown. Okay. And look for a proper overhang in an intact flue lining protruding. It says 1 to 2 inches above the crown. It actually should be 4 inches. And there's also no caulked bond on there. So that's about the end of what I've got. Here's a couple helpful links. Again, that bottom link here is that inspection video with Nick looking at that fireplace. You got 2021 IRC Chapter 10 on chimneys and fireplaces. InterNACHI.org is also, always your best place to look and take that fireplace, stoves, and chimneys course if you're wanting to brush up. Thank you, guys. That is my cell. Feel free. I don't really care. I get a million spam calls a day anyway, so my iPhone will warn me if you are somehow a spammer, or you'll sneak through and I'll talk to you for 5 minutes and we'll get over it. But if you got any questions, shoot me a text. Better to get me at that email, matt@trinitypllc.com. But have at it. Good to see you guys.